Good morning, everyone.
Good morning.
Good morning.
Good morning, Arthur.
Good morning.
So I have a favor to ask you.
Yes,
Can you help me keep track of time?
I can do that. How
Okay.
will you know? Should I chat? Should I? What works best for you?
Well, let's see. Texting would work, or you could just speak to me, interrupt. But
Okay, I'll just do time check whenever it's like 5 minutes before the end of a presentation.
yeah,
Okay.
I think that's the most direct. You don't have to sneak and tell me, just announce it to people. I think we could get started. That's right, isn't it? Morning, Colin. Good morning, Mark.
Good morning, Commissioner.
We're live.
I know. And good morning, everyone. Hi, I'm Cynthia Hall. I'm the Commissioner from District 1 at the Public Regulation in New Mexico. I'm really pleased to see we have 41 participants already today, 40 now, somebody dropped off. This is a workshop that the PRC is conducting in preparation for conducting definitely a rulemaking on the new interconnection rule that we hope to develop to modernize our current interconnection rule and manual. And we're embarking on this effort because it will help us in a very meaningful way to have the most effective rollout of energy transition as possible in our state. As I assume most of you know, we passed a law in New Mexico in 2018, the Energy Transition Act, which will result in New Mexico's electricity being derived directly from renewable energy sources. 80% of our electricity will be from renewable energy resources by 2040 and 100% from clean energy sources by 2045. So, but in order to do that, we have to take advantage of the great array of distributed energy resources that there are forming in the state. And this rule will be critical and pivotal to our ability to most effectively use those resources. What we hope to accomplish with this project today, with this workshop today, is first of all, finding out from the utilities, the investor-owned utilities, that's PNM, El Paso Electric, and Southwest Power Service, exactly what their state of affairs now are in terms of implementing the requirements of the rule. And then we want to hear specifically what the new form of the rule will be. And the rule I'm referring to, the interconnection rule, is it's IEEE 1547-2018, which you'll hear more about further down on our agenda this morning from Dr. Rope from Sandia Labs. After our break, then we will have three very accomplished professionals who will be talking about best practices for interconnection activities. And then at the end is what I think is the most important part, is getting comments. As I stated in our flyer, our objective in this workshop today is to gather information that will help us identify issues that we can then work on through what we expect to be a series of working group efforts in the next few months so that we can identify issues that need to be addressed in our revision of our interconnection rule. So without further ado, I want to start in on the first panel. We have a pretty tight schedule here, so Arthur O'Donnell from our staff will be helping me keep track of the time. But I think right now we're just at 9:35, so I want to get started on the first panel, which is the status of utility interconnection practices in New Mexico. And I'd like to ask the people on the panel to introduce themselves briefly and their position, and then have at it. So it looks like first up is Andrea Contreras. There you are, Andrea. Take it away.
Thank you, Commissioner Hall. I'm going to go ahead and defer. I know Ryan is going to go ahead and kick off. Ryan Germain from PNM is going to kick us off. And then I will jump in after on the presentation.
Hi, good morning, Commissioner Hall. This is Ryan German, and I'm sorry I joined a little late. I had some technical issues, so I missed a little bit of your intro. But I just wanted to introduce the PNM folks on the call, if that's okay. And then I'll send it back to Andrea to go through her presentation. But I'm Ryan German. I'm one of the in-house attorneys for PNM. Leslie Padilla is another in-house attorney at PNM. She's also on the call. And Andrea, who's one of the presenters today, is our manager of customer interconnections. We also have Kathleen Larice, who's a director of customer operations at PNM. And then Mark Fenton, who's our executive director of regulatory, and Adam Alvarez as well, who's a senior project manager for regulatory. And we wanted to thank you for providing us the opportunity to address the issues involving interconnections here. They're certainly important issues to PNM. And if I could, Commissioner Hall, we did file comments on Monday in the docket. And if I could just summarize those comments quickly. There are two primary issues that PNM is facing now with customer interconnections. And the first is that we've had so many interconnection requests, especially in recent years, that we have a couple feeders that are at capacity or near capacity, which limits our ability to add additional distributed generation on those feeders. The second issue we're having is just with procedures and processes for interconnecting new technologies, such as storage, and also microgrids as well. We're starting to get some requests for microgrids. And we mentioned in our comments that there's a new tool before the commission now that the legislature passed. That's the grid modernization statute. It's 62-813. And that statute specifically addresses distribution system improvements to accommodate or enhance distributed generation on the system. So we think that that's a tool the commission could look at specifically to address the feeder capacity issue. And we recommend that the commission consider that tool as part of this inquiry docket. And then in the remainder of our comments, we addressed the 5 issues that were specified in the commission's initial order. And essentially, we agree with the commission that updating standards and updating definitions that are in the interconnection manual and in Rule 568 is something that should certainly be pursued, and this is the appropriate place to do that. So with that, I just want to say thank you for allowing us the opportunity to comment and participate in the workshop here today and in future workshops as well. And I'll send it back to Andrea now.
Andrea, we can see your screen, but you're muted.
Okay, so you can now see the presentation. Apologize. Okay. Appreciate the time and allowing me to and PNM to present on this topic. Kind of as Ryan mentioned just previously, our path forward and the new grid modernization project under that NMSA 1978 section 62813 legislation and future applications will allow for utility grid investments considered under this grid mod project and costs recovered through a grid mod rider rather than the individual interconnecting customer. As Commissioner Hall, you mentioned the new inverter technology, IEEE 1547/2018, that will also be addressed, and potential approval of AMI to allow for utilization of these smart inverter technologies. Amendments to Rule 568 and the New Mexico Interconnection Manual, policy for considerations on socializing costs, rate design, net metering considerations in future regulatory proceedings, as well as adding standards to address energy storage technology, which we have already seen currently applied for, as well as what Ryan mentioned for microgrids. We are starting to see those being requested, and the community solar requests. Fee schedule revisions and application timelines like to be addressed, as well as new established timeframes for installation of approved applications to prevent customers from sitting on applications and preventing other customers from interconnecting. As I go through the slides, you'll see with the amount of approved applications, if we don't address some of these, we end up holding and reserving capacity, preventing customers that may be ready and in a queue that is preventing them from interconnecting when we don't have these other customers moving forward with their installations. So application timeframes. Currently, the status in New Mexico Interconnection Manual does mandate requirements for the reviews, the application once received, and then its review. So at the end of 2020, December 31, 2020, PNM had interconnected just roughly 23,488 interconnections with a total capacity of about 161 megawatts of capacity AC. As I go through the slides, you'll see in some of the future slides that this was really a record year in 2020 for PNM. We had a total of 6,598 applications in 2020. We ended in December with about 550, which was one of our lower months. So it actually gave us an opportune time to be able to catch up and then process some of these interconnections for these customers, as that we know they were wanting to take advantage of the tax credit. So we were able to process some of those. But when it comes down to PNM's responsibility in meeting those status timeframes, when we have applications for initial review, we have that limited 10-day review. So even with the record number of applications, we were still able to meet that 10-day timeframe for our initial reviews once received, and all documents are uploaded by the customer. Our technical reviews, we're still meeting at the 15-day timeframe limit with record numbers of technical reviews that we had on applications, as well as the other reviews that we hold per the guidelines. So in looking at 2020 stats compared to 2019, as I mentioned, 2020 was a record year for us. We had a 44% increase in applications. We were able to interconnect 17% more customers and systems in 2020 than we did in 2019. Part of the kind of anomaly here is when COVID hit in March of 2020, we were kind of under that impression that we might see a slowdown in applications, but I think contractors and customers, or really solar contractors, took advantage of the customers being at home. So even since April, we started to see that uptick in applications, and you can see from June, July, August, it just never stopped. We had a record month, I believe in October, so it was October timeframe or so, that we had over 820 applications that we received in just 1 month. But typically we were ranging anywhere from 600 to 700 applications per month. So that was a huge increase for applications for solar requests. And the trends, this is what PNM has seen. We've continued to see just an increase since 2016 in interconnections, and we know that's just going to continue to grow with our customers. So coming to what Ryan had alluded to for feeders at capacity, we have presented on this before. This is kind of just a snapshot for what PNM is currently facing. We have 18 out of 492 feeders, which is roughly about 4% of PNM's feeders that are at greater than 90% of its rated capacity. Currently, there is about 14 that have already maxed out at 100%, and then 4% are, or 4 of those feeders are roughly between that 90 to 100%. Any type of system improvements that would be required to allow for additional capacity are in excess of $1 million, and that goes up from there in order to be able to add additional capacity for interconnecting customer requests. Some of the risks that we see on these feeders at capacity is that thermal stability of the feeders in the decrease of load. Once we start interconnecting additional customers, that load begins to decrease, and we can start seeing potential voltage issues as well as thermal instability. PNM did in 2020 create that feeder capacity map. We have demonstrated it multiple times, I think to different stakeholders, as well as to the commission. We've had multiple contractor coffees with our customers to ensure that they take full advantage of this feeder capacity map. That'll allow them to go in and enter an address or look at and I have another slide that'll kind of show a little bit better info on that, but allows them to enter an address or look at a location on PNM's map and determine if any of that area that they're seeking to install solar will allow for additional interconnections. We are asking with this inquiry that additional language possibly be recommended that prohibits contractors from installing systems prior to approval. I'll kind of mention in a future slide as well that, we have this holding queue of customers that are waiting to install on these feeders at capacity where they have full systems built. Contractors went ahead and pre-built their systems without receiving full approval from PNM through the technical review, screening, and installation process. PNM has made an internal decision not to charge customers for supplemental review per the interconnection manual. If during the screening process an application fails, we would typically push them into supplemental review, charging the customer the $44.10 in order to be able to send it for additional review. But because we know that these feeders do not have any capacity right now, PNM has made the choice to not charge them and be able to allow them to stay in that holding queue until we can actually free up either capacity or have some sort of system improvements made to allow them to interconnect. Once the customers identify that they are on a feeder at capacity through the reviews that the team does, the customer is given the option to either stay in the holding queue or they can go ahead and withdraw and cancel their application. An application is never rejected or denied. Oh gosh, my mouse is rolling. Sorry about that. So Rule 568, some of the capacity constraints that are limited with these feeders reaching their max capacity, and per Rule 568, if an upgrade is required, it's solely to accommodate a customer's PV interconnection. It's considered a system improvement, is solely the responsibility of the customer. The cost of these upgrades, as I mentioned previously, are well in excess of $1 million that we don't anticipate a small residential customer to be able to pay that. As part of the recent inquiry docket, PNM recommends that the Commission consider potential remedies or policy considerations related to this issue, including whether the cost of feeder upgrades to accommodate solar should be socialized among all users of the distribution system and not just recovered from the individual customer requesting the upgrade. So these are some of our main numbers for feeders at capacity. Gosh, I removed the feeder names just for safety concerns for the feeders that are listed. But currently, this is our application queue and count of customers. So in 2020, when this decision was made to limit the customers from interconnecting on a feeder at capacity, we had 123 customers that are in the queue waiting for additional capacity. And so far for 2021, we have an additional 17 customers. This is on 13 of the feeders that have already reached that 100% max capacity. If we were to try and interconnect these customers on these different feeders, we'd be looking at about 770 kW of interconnection generation AC that we'd be looking to add on to these feeders.
Andrea, I just want to let you know you've got a couple of minutes left, and then we have to move on to the next company.
I've got 2 more slides real quick.
Okay.
This is just the solar capacity map that I mentioned, giving the customers the option. They go in and enter an address. It'll pop up whether they're green, yellow, or red. This is kind of where they see that main page where they can see those red areas for feeders that are at capacity. This map right here is the usage map that PNM gets to see how many contractors are actually utilizing this solar capacity map to determine whether they can interconnect a customer. So we greatly appreciate that they're continuing that usage of the map. We have had increased hits really high in end of 2020, as well as continued into 2021. And this just runs through the FAQ page that the customer will receive on that capacity map, letting them know if there is capacity available, could be a potential if we're in that 90% range that's nearing capacity, or if we're completely maxed out at capacity. And still gives them the option, no matter what, they pop up up here, to be able to apply and put themselves in that holding queue for additional interconnections when capacity is available. So thank you for the update, Commissioner Hall. That was my time limit. And if there's any questions, that was my presentation.
You're on mute, Commissioner Hall.
Thank you so much, Andrea. I really appreciate it. And Ryan, thanks. It was great to hear from you. And thanks very much, folks from PNM. So now we're moving on to, I believe it is El Paso Electric. And we have Joe Garibay. Is that correct? I see you up there, Joe.
Yeah,
William
Joe Garibay.
Okay.
Cynthia?
Yes, Steve.
Commissioner Fishman. Yeah,
Commissioner Fishman?
Is there room for one quick question for PNM?
That wasn't really the plan until the
Okay,
comments.
I'll follow your plan. I haven't seen the.
I'm sorry, Steve. I just want to get through everybody so they all have an opportunity to talk. So take it away, El Paso.
All right. So I am Joe Garibay. I am the Director of Customer Care for El Paso Electric. With me today, I have Ty Pollard and Roberto Favela, who will be handling the technical aspects of the presentation. And let me see if I can get my screen share here. Do you all see the presentation?
Yes.
All right. And so one of my areas at El Paso Electric is the distributed generation team. We have 8 employees on that team, and the function of this team is to be the coordinator between the customer, the installer, and EPE on applications. And get this, go to the next one here. Okay, there we go. As you can see from this chart, we process about 1,100 to 1,200 applications a year based on the last 2 years of data. That's when we saw the most applications. So it's just under 100 applications a month. As of end of year 2020, EPS had 5,739 DG customers with a capacity of 32,090 kilowatts. Our average system size in 2020 was 5.58. The average system size for all DG customers, 5.59. So 2020 was a pretty indicative year of what we've seen through the lifetime. Any given time, EPA will have 50 or 70 applications in process. Most of the times when they're in process, what we're dealing with here is actually just the installing of the thing. We have very few delays, if you will, or changes between what's going on with the customer and EPE in terms of getting the applications processed. EPE uses an online application process. It's based off of the steps that are in the simple application steps that are in Rule 568. The steps do require signatures at some point. At those points, the responsible party is sent an email telling them, hey, you've got either a signature due here or we need some information. There might be a couple of days delay there. If any step goes too long, an alert is raised, which is given to one of the DG teams, and they'll reach out to the individual, whether it be on our side, the EPE side, or with the customer to get the process moved forward so we can keep things going. EP does strive to get DG customers on the system as quickly as possible so that the customers can start receiving the benefits from their DG system. Any questions or anything on any of those slides? Or if you want to do questions later, we can do that. Okay, I'll go ahead and turn my presentation over to Ty, who will talk really about the technical aspects on the system.
Good morning. My name is Ty Pollard, and I'll be following up here with some of our current practices. Right now, there was a question posed about distributed generation hosting capacity and how we determine that. And what we do is we use our feeder ratings and total connected distributed generation to determine what is available. Hosting capacities are determined at the time of the request on a case-by-case basis. The capacities are determined for systems that have an aggregate production capacity of 1 megawatt or larger. And currently there are no hosting capacity limitations for systems smaller than 1 megawatt. All right, Joe, next slide, please.
Okay.
To give you an example, we selected one of our feeders for Nada 21. It has a maximum rating of 18.7 megawatts and has 1.6 megawatts of connected DG at the time. The current hosting capacity would then be communicated as 17.1 megawatts. And at present, we're not getting the influx of connectivity that PNM currently has. So our plan is to reevaluate the hosting capacities of the feeders when aggregate connected distributed generation reaches 110% of the feeder rating. And this is with exception to our network. Our network system, we do need to evaluate every system that does apply. So Joe, if you can move on to the next slide, please. And just to give you some updates on some of the things that we're currently following up with for voltage and frequency ride-through. We have been implementing IEEE 1547-2018 as of last year. We haven't had any new applications or new large distributed generation facilities connect to us since the new standard, but we have had a facility, we did work with a large facility in Las Cruces that was having frequent operations due to system transients and other impacts that were not on their source feeder. So we've adjusted our protection settings, which allow the customer to implement changes in alignment with the new standard that allows them frequency and voltage right through. And it does appear that it has improved performance significantly, or we expect it will. And EPE plans to implement these improvements on other sites within our service territory. So currently we have a handful of sites in New Mexico that we need to revisit. And going forward, we're going to adopt the guidelines for any new large distributed facilities that intend to connect to us. And I think that's it, Joe. Thanks.
Roberto should have this one, or is this one yours?
Yes. So my name is Roberto Favela. I'm the manager for system interconnections at El Paso Electric. Primarily, we handle the FERC and we coordinate with distribution on any large system interconnection on the distribution side. We currently do not have any specific comments addressing this rule, but we agree that the manual needs to be upgraded and it needs to be revised to conform to new technology and the new practices. We are recommending that, the start of a series of workshops that we can address the technical and logistical upgrades or improvements we can make to the manual, to the interconnection manual. We have been, those workshops have proven quite productive in the past in several other states and also for New Mexico. And I think that if we have a joint effort between PNM and the investor-owned utilities, we can really produce a quality product. So EPE is willing and eager to upgrade those manuals and in a way that it's a win-win for everybody.
All right.
There's
And
any
that
questions?
concludes, I think they want the questions at the end. So that concludes EP's presentation.
Well, that's fine. You're 9 minutes ahead of time, so that might give us time for some questions at the end of the panel. So let's see. It depends on how long Ruth Sakya takes. Are you there, Ruth? That's who I have up for Southwest Power Service. Do we have?
I am,
Ruth?
Commissioner.
Okay, great. Do you want to go ahead and present for Southwest Power Service? You've got roughly 17 minutes.
Yes, and I also have with me Kyle Riddell, who's
Yes.
going to speak.
Great, thank you.
And then, Kyle, do you want to share the screen since you'll be giving most of the presentation, and I'll go ahead and just get started?
Sure. Yeah, let me do that real quick.
Okay, you're probably more technologically proficient than I am. So Commissioner, thank you for having us. I'm Ruth Sakya. I do a lot of the regulatory filings, and I've been involved with SPS's DG filings since the beginning of time. And while I wasn't our technical person, I sat through the commission's process when we did the interconnection manual back in the day. It was very long, but very fruitful process. And then Kyle is one of our expert engineers who works on the system. So as you can see, we have a very brief presentation today. I'm going to bet we give you some time back so that the commissioner, and I saw there was a couple of other questions in the chat. I'm just going to present one slide and then I'm going to turn it over to Kyle, who will go into more specific details related to interconnection. Most of the connections on our system are solar, almost the entirety. We have a couple of small wind systems, but I didn't put those statistics on there for you. But to date, and these are still preliminary, we're still getting our final numbers, but we have about 483 systems on the system. 36 have come in so far this year, just in the month and a half of 2021. In 2020 itself, we had 144. And then in 2019, we had 66. So you can see just the last 2.5 years, we had a pretty good outlay. And then I don't know if your screen is showing what mine is, but it kind of went blank there.
Sorry.
And then, and forgive me for drinking some water there. Of the systems installed through the end of 2020, most of them are on the residential scale and about 107 small business and commercial. And then Kyle, I'm going to turn it over to you.
Okay. Good morning, Commissioner Hall. Just to go through a few points talking about our interconnection processes and what we look at as far as the screens for interconnection applications. In general, SPS has not experienced any major constraints that have prevented any interconnections at this time. Some of the things that we do consider on these requests is the minimum daytime loading of the substation, and the fact that in many locations, these interconnections would be limited to less than 5 megawatts in order to prevent power flow back onto the transmission system. Interconnections greater than 5 megawatts or those that exceed the minimum loading on the substation are studied by the Southwest Power Pool because of the impact that they would have on the transmission system. Feeder capacity constraints are also something that we consider and look at, and could depend, they could exist depending on the proposed location of the interconnection and the proximity to the substation. Sites closer to the substation would have fewer constraints, whereas those further out on the feeder would have more. Looking at the size of the interconnection, anything in the realm of 5 megawatts would would exceed the 15% of total feeder capacity for just about all of the circuits, which would cause us to take a further look at those interconnections and what we need to do to be able to maintain voltage and both the steady state and for loss of the generation of the interconnection, so that we can maintain the reliability of the system to the remainder of the customers on those feeders. So talking about the screens to determine the capacity for smaller interconnections, we do perform an engineering review to verify the inverter equipment meets the applicable standards, and that all of the equipment that is supposed to be there is going to be installed. As part of that review, we do look at localized system impacts, so secondary conductor loading and service transformer loading, but we've not experienced instances yet where we have constraints to back up the interconnection process on these smaller interconnections. For larger interconnections, which we have not had very many of these at this time, but the generator size is considered again to determine if flow back onto the transmission system will occur, and then system impacts are identified as a result of those studies. So basically all the constraints that I talked about on the previous slide would be addressed with that study. And so that, again, if the generator size exceeds 5 megawatts or will result in flow back onto the transmission system, that interconnection would need to be studied by the Southwest Power Pool to identify the transmission impacts as well. So tools that we can use to alleviate constraints when they do occur: reducing system impedance through rerouting of lines or reconductoring of lines to upgrade the conductor size, specifying a power factor for the producer to mitigate the voltage rise and flicker at the point of interconnection, and also utilizing active voltage control equipment, on-load tap changers at the substation, voltage regulators and capacitors would all be in play as far as system upgrades that we'd be looking at. So that does conclude our presentation of prepared remarks at this time.
Well, thanks very much. Okay, so this panel was scheduled to go to 10:25 and we're at 10:07. We have some extra time, and I was noticing that we have Luis Reyes in the group, I believe. And I was wondering, Luis, if you had the inclination, would you be able to address the concept of what's the status of interconnections with respect to the co-op perspective? I mean, I know you're not the typical co-op, but and for those of you who don't know, Luis has a very outstanding co-op that's been able to deliver a tremendous amount of renewable energy resources to his footprint, his customers. But nevertheless, I'd be interested to hear what you have to say, Luis, and then depending on how long you take, we may well have time for comments before the next speaker is scheduled at 10:30. So what do you say, Luis? I see you're there.
Yeah, so Commissioner Hall, thank you. And again, I can really only speak for Kit Carson. Don't want to say what other co-ops are doing, as I really don't know what they're doing. I can tell the group that Kit Carson currently has about 600 behind the meter applications installed. I think, as mentioned in the previous presentations, is we use the interconnect standard or manual with pre-screens and to qualify. We look at feeder loading. We do all of the same things that the other utilities do. I think the one thing that we're starting to be challenged with, and Commissioner Hall, I want to be careful because we do have a couple of complaints, so I don't want to get into any ex parte discussions. We do have I believe at least one formal complaint related to behind the meter. But in general, so if I do say something that is uncomfortable, stop me, because I don't want to go into the ex parte area. So Kit Carson
Just
has
avoid the
taken on.
cases, avoid specific cases.
Okay,
That's
so
all.
Kit Carson has taken on building its own DER network integrated into its distribution system. And so by the end of this year, we'll have enough capacity and energy to cover our daytime needs of our members. And we'll probably have about 16 different installations, everything from half a megawatt to 15 megawatts, placed in close proximity of substations that Kit Carson owns and controls. And so when it comes to behind the meter applications, we're actually trying to determine how to best address those, as they'll be attached to feeders that will have 100% penetration of Kit Carson solar facilities. And so do we address that in utilizing batteries to store the energy that the solar outside of the self requirements, so that we can deliver that energy that's generated during the daytime at nighttime? Do we just right size, just to size the array just so it meets the customer's needs and has, in essence, no ability to export onto our distribution? And then, as it's mentioned, we have, I think by the SPS presenter, we do have transmission contracts with both Tri-State and PNM at this point that do not allow any backflow into the transmission system without studies or maybe changes in the tariff. So it's not as easy as just getting all the excess from behind the meter and trying to get it to a marketplace. We just don't have the legal ability to do that. The capacity is there. The transmission lines that come into Taos are 345 kV, and it's interconnected into the 345 of PNMs. And so we are struggling of how do we continue to enable behind the meter safely and responsibly. But right now we may on some feeders have no ability to take their energy. And it's system-wide, Commissioner Hall. It's just not one feeder that I know with Otero Electric. There was an Air Force base that built a lot of solar at the Air Force Base that basically made the three-phase line that they built not needed anymore because they now had enough capacity of solar. Ours is a system-wide issue. And so that's what's happening at Kit Carson. And the other thing too in our strategy is, since we do have a broadband network, if there's ways to, and we can look at inverters, basically the inverter in real time. And so if there's ways in which we can control that in real time and have the software to control it, then maybe we could come up with some strategies of where we control storage behind that benefits both the co-op at its peak time and also gives a financial benefit to the behind the meter consumer. But again, some of those we're working on. And the other thing that we've done is since last January for a year, we formed a committee of members, both members who had solar and members who did not have solar. And we meet basically every month for the past 12 months to try to find some local solutions of how to create a win-win, both on the technical and also on the financial. There's always a talk about what the credit should be for any excess energy. And so we're trying to mitigate any potential or perceived subsidy issue that may occur because the excess is credited or sold at retail. But it's been pretty effective. It hasn't caught, there's been a couple people complain, but for most part, we've educated the community of the benefits of behind the meter versus in front of the meter. We brought rate consultants to help us maybe determine a rate design that works for behind the meter in this new kind of DER world. So we've been very active with our membership at finding a solution ongoing, because I do think it's going to continue to grow. You know, if Kit Carson, who has 600, you know, just in New Mexico, that's more than SPS, which is a utility that's 20 times larger than, and so we have a very active community in solar here. So those would be my comments on what Kit Carson's doing and the challenges we have related to behind the meter application integrating with a DER system that Kit Carson's building.
Commissioner, you're muted.
Thank you very much, Luis. I truly appreciate you stepping in just right off the cuff. And I want the crowd to know we were trying to line up someone to speak for co-ops. And now I've been notified that there's another person, Kevin Gronwald, who's the head of the New Mexico Co-op Association, also present. And Kevin, I don't know if you'd be interested in making any comments. I apologize for asking you just right at the such short notice, but if you're interested to, please unmute yourself. As I said, the purpose of this workshop today is for us to get as much information from you folks as possible. And I see we have a ton of questions. If you don't want to speak, Kevin, I don't see you popping up. So maybe.
Commissioner, I'm here.
Oh, wonderful. Kevin, I'm sorry to ask you on such short notice, but we really did want to get co-op perspective. So if you can speak to any degree about the remaining co-ops, please give us your thoughts.
Well, thank you, Commissioner, and everyone. I can't talk any specifics. A lot of the co-ops, they have their own policies. They operate according to their own board guidelines and policies. What I can say is, we're talking about capacity. I was on the original working group back in 2007, 2008. The capacities for feeders was set at that level to make sure that there was never any backfeed into the systems. I think Mr. Reyes mentioned that we've had a condition down in Otero where that has happened, where they added several hundred rooftop units to some base housing at Holloman that has caused some backfeed problems. One of the co-ops, depending on where they get the requests for interconnections, are different. Out in some of the very rural areas, they fall through the screens and they're just interconnected. The larger systems, if it's in a more densely populated area, we can run into some density issues. But I just think in general terms, from the co-op's perspective, we're going to be participating in this. There's some updates I think need to happen. As you talked about earlier, the new inverter standards were something that wasn't considered back at the time. Storage was never considered in the original working group because storage really didn't exist at the time. There may be the need for upgrades as far as feeder loading. It was set pretty low at the time because no one really had a whole lot of working knowledge of distributed generation and the impacts on the system. But the co-ops in general will be a part of this. I reached out to the members and asked for some participation by the engineers from our distribution co-ops that do have a good working knowledge of this now, because co-ops have anywhere from, some may have just a small handful of DG and some have several hundred installations. We got a wide breadth of I think experience out there, and we're gonna provide that knowledge into this working group and as we update the interconnection manual. But Commissioner, that's about the extent of my comments now.
Oh, let's see, where's my thing here? Thank you very much. I really appreciate it, Kevin. So it looks like we've got about 5 minutes, 6 minutes maybe, and maybe we could go through some of these questions then. Looks like the first one is from Stephen Rhymeshaw. How is feeder rating determined? Let's see, and I'm not sure who was speaking during that time. Do any of the panelists want to take a crack at answering that?
Sure, Commissioner. This is Typewad from El Paso Electric. I believe that was on our slide with regards to feeder rating. And what we do is we use the rating of the least rated component in the main trunk of the feeder circuit. That's what we're advertising as our feeder rating. We use that consistently.
Okay.
I'm sorry, you were crapping out there, Ty. Could you please repeat that?
Sure. So it's the lowest rated component in the main trunk of our circuit, of our feeder circuits, that it drives the feeder rating. It could be cable regulators, it could be switches, it could be any electrical component in the main trunk.
And I'm sorry, you're adding up the capacity of the load on that, and then adding any generation on top of the load in order
No, it's all for determining capacity. We use the aggregated production that's connected to the system, and we subtract that from the rating. So we're not using any load values at all. It's total production that's connected per its rating. Aggregated production.
And your threshold is 100% of the rating or some other level?
Our hosting capacity is 100%. That's the limit that we've drawn, but we expect that over time we're gonna reach this 110% of connected production, aggregate projected production. And at that time, that's when we're gonna review and analyze system performance. A reason being is that we have large distributed generation facilities that have connected, and we have seen overproduction from those facilities. So we're confident that at least the circuits that we're monitoring now with those high production connectivity or with high production connectivity, that we can manage up to 100% of connected rating for production.
If I may just ask another question based on your presentation, and we'll move on. You referenced that at least for one customer, you're now using IEEE 1547 2018 for voltage ride-through and frequency ride-through. What impact do you see that having?
So my understanding is that the site was frequently operating due to the, I guess originally I think there were this site was installed 2011. So with those standards, the under voltage, over voltage, under frequency, over frequency settings were really tight. And we, when implementing or supporting that system, we set our protection settings right outside of those boundaries. So the system could feel transients that were adjacent to the source circuit or from transmission and other events. So they were having frequent operations. Last year, we came back to the table. We relaxed our settings significantly. We're in alignment with category 2 within the standards as far as shall ride through or must operate suggestions or requirements in that category. And we haven't had any, I guess, communication that they've had issues since then. So we believe that it is going to improve performance of that site specifically. And we hope to extend that to the other sites that we have in our service territory.
Thank you very much, Commissioner.
Sure.
Thanks for the questions, Arthur. Sorry, folks, for letting Arthur take cuts, but he's on our staff and we're trying to get as much information as we can. So, but we've got time for one more question. Commissioner Steve Fishman's question. Does behind the meter storage have any impact on the stress a solar system puts on a feeder? And Luis Reyes responded that will depend on what the purpose of the battery is being used for. Does anybody else have any further response to that question of the panelists that we spoke to. And the question is, does behind the meter storage have any impact on the stress a solar system puts on a feeder? Any comments from anybody?
This is Ty again. Real quick, what do you mean as far as stress? We do believe that power quality issues are introduced depending on the amount of production that comes into or where the production is entering. I guess the system. So, is there a specific reference to stress? It could cause power quality issues. We've seen that high voltage or voltage fluctuations, different things like that.
So Ty, this is Commissioner Fishman. I was wondering if it impacts the capacity of solar that can be put on a feeder one way or another. And I suppose it does depend on use. Are you storing all the power in a battery and not allowing any to go back onto the feeder? Or so I'm just trying to get a sense of that.
Oh, okay, yeah. It does depend on how much production is going back into the system. If the amount of production results in currents that are in excess of ratings of system equipment, yeah, it could cause problems.
Thanks.
In connection with that, I see there's another comment from Andrew Stone saying, let's say the purpose is for the battery to dispatch in response to utility signal to meet peak demand. What about with that purpose? Ty?
I can't really respond to that. I apologize. I'm not as familiar with battery technology yet. So yeah, I'd really like to be involved in these future workshops to get educated on that.
Okay.
I could chime in on that one real quick. This is Roberto.
Okay, thank you, Roberto. Go ahead.
Sorry, I can't get my camera to work, so I can't turn myself on. But the dispatch, this is the new technology where, we're going to have some AMI or advanced metering where dispatchers will be able to utilize stored energy of those batteries to dispatch and address system needs during peak loading. So this is something that definitely we can address, but it will require high-speed connectivity so that dispatchers can activate individually or on aggregate groups all those batteries so they can be called whenever it's needed.
Great. Thank you very much. Steve, does that help you?
Mm-hmm. I'm good.
Great. Okay, let's see. We're at 10:27. And we're scheduled to start with Dr. Ropp at 10:30, so we can maybe squeeze one more question in if anybody wants to do it. Here's a question for Ruth and Kyle. Can you provide a link to the SPP study requirements? Kyle,
we can.
Ruth? Okay.
I'll have to find that, and if I don't have it by the end of this workshop, Commissioner will get it. Maybe everybody it can be sent out to the distribution list.
Okay, and that was a question from Lance Adkins. It's in the chat. I hope we're saving the chat so people can share it. Isaac, if you're listening, please let me know. And here's a question from Darren Zigich. It appears that feeder loading criteria, the thresholds, are not consistent between the utilities. Why is that? Anybody want to jump on that question? Darren, it doesn't look like anybody has a...
Commissioner, this is Kevin Gromwald.
Okay.
I think it depends on the feeder. If you're on a very rural feeder, say a few hundred kilowatts of load on a feeder that may be several miles long, the loading is going to be different than, let's say, if you're in a community where you have much more dense energy usage. So it's gonna vary, I think, depending on your feeder characteristics.
Okay, great. Thanks.
Thanks, Kevin. This is Darren. What I was highlighting was, El Paso seems to have this 100% threshold where everybody else is using that 15%. And I don't know if those are apples to apples or if that's something else. But it seems like there was slightly different criteria there.
This is Kyle. I think I was the one that referenced the 15%. And I wasn't saying that was the hosting capacity limit, but that would be the trigger to cause us to go into a more in-depth study. But we would also be looking to use the 100% limit for hosting capacity on the feeder.
Well, I'm sure this is going to be an issue we take up in a subsequent working group. So Darren, stand by, and if you'd like, please participate, as well as you, Ty. But we need to move on now to Dr. Mike Rope from Sandia Labs, who's going to be talking to us about the standards and technical opportunities of the new version of the IEEE 1547 rule. So thank you, Dr. Rowe. Please proceed.
Thank you, Commissioner. Are you able to see my slides?
Yes, they're very nice. They're very nice, and they're all visible. Yeah.
Thanks. Good morning, everyone. This is Michael Ropp from Sandia National Labs down here in Albuquerque. I would like to talk to you a little bit today about the new IEEE 1547-2018 and its companion standard, which is 1547.1-2020. Lots and lots of numbers flying around. Talk about some of the tools that those new standards give us for solving certain interconnection issues for distributed generation. And I don't know for sure what the question situation is. I've tried to allow some time at the end for Q&A. So, Commissioner, is that okay if we take that at the end of this session here?
Well, if there's time, that's fine. And if you're not going to take up the entire half hour allotted to you, then yeah, we'll proceed with questions. I think it helps tease out more issues that we're trying to identify through this process. So that'll be fine.
Okay, very good.
But that doesn't mean rush. You don't have to rush either. Just
okay.
We're here to learn. This is a learning experience for we at the commission, anyhow, for us at the commission.
And for me as well, because I'm going to address primarily technical issues here. There are, of course, many policy issues and contractual and economic issues that play into this as well that are very important, but are just not a part of what I'm going to talk about here today. So others will cover those. So as you know, a distributed energy resource, according to the IEEE standards, is defined basically as any generator or energy storage that is not connected to transmission. It's connected to whatever the utility defines as distribution. There are several challenges that if I start putting large amounts of distributed energy resources, or DERs, on a distribution circuit that can arise. Several of them have been mentioned already. One of them is voltage regulation on these circuits. If I put too many DERs toward the end of a circuit, it can start pushing the voltage up in ways that the utility may find difficult to regulate, which can cause problems. One issue that is frequently cited is the risk of formation of an unintentional island. I'll tell you more about what that is in a minute and how we try to deal with that. One is that as we start adding more and more DERs in the distribution level, there can be enough of them that they actually start to impact what happens at higher levels in the system. So we need to be able to assess and address those impacts in the behaviors of the DERs. One of them is we need to be able to protect distribution circuits. In other words, if I have a short circuit, I've got a wire on the ground or something, the DERs cannot impede the ability of the utility to de-energize that line and
Dr.
protect
Rowe,
both.
I
Yes.
apologize for interrupting you. We got a question saying, can you roll the slides? Are you moving through your slides?
I did advance to the second slide. Is it not showing on your screen?
No, it's not.
You're still on the title slide?
Yes.
That's a problem.
Okay, there you go.
Drop out of slide view here for a moment.
It shows now. The second slide shows now.
Okay, we'll try presentation view one more time, and if it doesn't advance, then I'll just drop back to the other view. So sorry about that. Yeah, so I was reading this to you without showing you what it was. Another issue that has been very important recently is communications and what is referred to as interoperability. Basically, we need different manufacturers' equipment to be able to talk to each other. or else you become committed to just one system or one proprietary standard, and that causes risk for customers and for utilities. One, of course, is the lack of dispatchability. Dispatchability means that I command how much power it produces up to its limit. And of course, with solar and wind, we're dependent on how much sunlight and wind there is. You notice that one issue that has already been mentioned by a couple of our utility speakers is thermal loading of lines. I didn't address that here because that's not really something that is addressed directly in 1547-2018. The question came up a little bit ago about whether energy storage could have something to do with that. And my experience with that has been yes, depending on how the battery is used, exactly as was suggested, that you can use energy storage to level the output of a distributed energy resource. And then you have to have an export limit above which you don't export anything back to the circuit to make sure that you don't overload whatever component is being overloaded. So the energy storage can help to relieve that issue in certain contexts and if the storage is used in certain ways. So I advanced the slide. Did you guys see it advanced this time?
No.
No, cannot see. We're looking at slide 2. Now we're at slide 3. So I guess I have to do this manually.
Yeah, sorry about that. We'll stick with this view for now because it appears that when I do the other one, it's not showing you the right slide. So when we wrote IEEE Standard 1547-2018, which was the previous update had been in 2003. So industry had changed a lot since the original 1547 was written. The new version, which unfortunately is much, much longer, tries to address a number of these issues by requiring inverters, the interface devices, to have a number of capabilities that can be used to solve these problems. One key thing to bear in mind is that the standard requires that the inverters have the capability, but it does not require that the capability be used. Use of the capability falls to the system operator, the utility, in mutual agreement with the person operating the DER plant. So the kinds of tools that we're going to go through here, and I'll show you some examples in just a moment, are, number one, there are several inverter control modes that are specifically designed to help keep local voltages within the tolerances that they need to be kept between to avoid damaging equipment or shortening its lifetime. So these modes are being used in circuits today with quite a bit of success. I'll tell you the pros and cons of the various methods here in just a minute. I think it's actually on my next slide. I mentioned before that these problems with, if I have large numbers of DERs, how do I keep that from adversely impacting the system above? The new standard requires these low voltage and low frequency ride-throughs. Basically, as was mentioned before, I think it was Ty from El Paso mentioned this, that the 2003 standard was very twitchy in the sense that if there was any kind of a problem on the system, we told the DER to get offline and let the system deal with it as it normally did. Now we've got enough DERs out there that we don't really want them to do that because it causes another problem if they do. So they are required to stay online much longer through much larger deviations in the voltage and frequency so that we don't get these big drops in resource right when we need it the most. There are some frequency support functions as well. Some of you have probably heard that the ERCOT, the Texas system operator, saw just a couple of days ago, they saw the lowest system frequency they've ever seen. And part of the reason for that was, a lot of generation assets had dropped offline that weren't expected to. In a case like that, you need your DERs to be able to take certain actions to help you out. So some of those capabilities are also in the new standard. The new standard actually has the word interoperability in the title. That's a very important part of what this standard deals with, to try to just establish some protocols and things to make sure the devices can talk to each other. So I'm going to go through a couple of these of the top issues that have been named by system operators as challenges they run into when DERs become widespread on their system, and talk about how some of these tools can be used to address those. So the first one, the challenge that we mentioned before, was the voltage regulation. The diagram that you see across the top there, that's a typical feeder circuit that's connected to a transmission or sub-transmission line. You see way over on the, I'm sorry, I keep pointing at my screen. It's my old academic self coming out again. Over on the right side of your screen, you see the little circle that says PV. So I have a PV plant there, or it could be another DER. It's connected through a transformer to the distribution circuit. That's those 3 lines that move on to the left from there. And you see a bunch of things dropping off of there. Those are loads or various utility equipment. So you don't have to worry too much about what that is. But that's my distribution circuit proceeding away from the grid out toward the PV plant. And if you look at the chart at the bottom, you see there's a blue trace there that says without PV. Now what that trace is showing you is the voltage as a function of distance away from the utility source. And normally the utility will take a number of actions to try to keep that voltage between those 2 red lines. And the purpose of the red lines is to make sure that the equipment does not either malfunction or become damaged because the voltage is severely abnormal. So what the utility tries to do then is stay between those red lines, and without the PV, you see the blue trace, the utility's got its equipment set up so that it does that. It stays within those lines. What can happen if I'm not careful is if I put too much PV out there, or if the PV is not operated correctly. I keep saying PV, but of course it would be any DER. I can move from the blue line to the green line, and you see what happens is I'm now pushing energy back up toward the utility. Normally, as power flows from the utility out toward me, toward my house, the voltage comes down a little bit. It's what we call a voltage drop. But if I'm pushing power the other way, the voltage drop reverses direction and the voltage goes up. So I actually can end up with that green trace there where for some parts of the length of that line, the voltage is actually too high. That can damage equipment. It can cause a lot of other issues. Now, these tools that 1547-2018 gives us, these various voltage control tools, allow us to control the inverters in the PV to bring that voltage back down to where the purple line is. So you notice it's kind of flattened out a little bit because there's not as much power necessarily flowing all the way back up. But none of it goes outside of the red curves now. That's our objective, trying to keep those voltages inside the lines. This is an example of one of the functions that's used. This is referred to by those of us in the trade as a volt-var function. So I just wanted to show it to you in case that term volt-var shows up. But basically what it does is it controls the inverter in such a way that if the voltage starts to go too far one way or the other, it starts changing the output of the inverter in order to bring that voltage back toward the limits that we're looking for. So this figures directly out of 1547-2018. How well do these work? I think this is probably one of the things that the commissioners at least are going to be the most interested in. There are 3 main tools that we use to do this. There are a couple of others, but there's 3 main ones. The first one is what's called fixed power factor or fixed PF operation. This is the most common solution because it's the simplest. And inverters have actually been able to do this for quite some time. Fixed power factor operation actually works pretty well. It can, under certain circumstances, bring us all the way back within those red lines and we don't have any issues. It's very simple. It just takes one setting in the inverter and I'm done. It's inherently stable in the sense that each inverter is doing this completely on its own. So you don't have inverters basically trying to pull things back and forth on the circuit. They don't fight with each other in that respect. The only drawbacks to this are that when I used this fixed power factor operation, it actually does put a little bit more of a burden on the utility. The utility has to supply a little bit more of what we refer to as reactive power, but it requires the utility to put a little bit more into the system to prop that up. So that's a disadvantage. Also, this does not automatically adjust. Once I set that parameter, it stays that way. So if somebody comes and adds another PV plant next door to me, I might actually need to change that setting. So I may have to restudy things and figure out what to do with that. It doesn't automatically adjust. The next one, I showed you that volt-var curve. There's also a volt-watt curve, which I showed here. Those do automatically adjust. There's some automatic closed loop control in there that helps us adjust to conditions as they change. You notice I have the comment in here that usually this is implemented in a plant controller at the PCC is the point of common coupling. That's the place where the utility and the DER meet. And usually that's the place where we want to be able to regulate the output of the plant. Sometimes you do it at the inverter terminals, at individual inverters. But in many plants, I've got more than one inverter. So the place where I want to control this actually moves up just a little bit. And I often have an external controller that's monitoring that point and then talking back to the inverters. It can be implemented in a couple of different ways. So the advantage of this one is that, as I mentioned before, it adaptively adjusts the output to try to keep the voltage in spec there. So it gives me an automatic adjustment feature that I didn't have with fixed power factor, and that's good. A couple of disadvantages. There can be some adverse interactions between inverters. If I have multiple inverters on one distribution circuit, all of them doing this, they have to be coordinated with each other a little bit so they're not trying to push and pull against each other. There are ways to deal with that. So it's not a big problem, but you just have to be aware of it. I mentioned here usually requires a measurement at the point of common coupling, not necessarily back at the inverters. So I may need additional measurement equipment, which can raise my cost a little bit. Some utilities utilize programs like conservation voltage reduction, or CVR. You have to make sure that this is coordinated with that, because the utility may be trying to adjust the voltage one way, but the DERs are trying to go a different direction. And it can, under certain circumstances, force the PV output to go down a little bit. The last but not least is this just closed loop voltage regulation. And the difference between voltage regulation and volt VAR is that in voltage regulation, I tell the PV plant, I want the voltage at the point of common coupling to be X. And then it measures that and says, yep, I'm going to hold that voltage right at X all the time. So it's in a sense, it's a tighter type of control, that it's directly trying to control that voltage at the point of common coupling. That gives me the best voltage control. It totally adapts to changing conditions. You can actually improve the circuit's voltage profile doing this if you do it right. But this one has the maximum potential for inverters to argue with each other. They're both trying to control the voltage. And if they don't have the right voltage set points, one of them will push all the way up and the other will push all the way down, and they'll just argue with each other. So it has to be coordinated across inverter installations. Okay, so I just advanced to high penetration challenge number 2. Hopefully you're all seeing the slide on unintentional islanding. So many of you may be familiar with this. Just in case anybody isn't, I've got another schematic diagram of a distribution circuit here. This whole thing that you're seeing here was one distribution circuit. There are 2 PV plants here labeled PV1 and PV2. Got loads scattered all along the circuit. And you notice there's this switch over here, this labeled feeder breaker. Now, a strange thing can happen if these loads, all of these loads, and the PV plants happen to exactly match up with each other. When that happens, basically there's nothing flowing through this feeder breaker over here. The breaker's closed, but all the energy being used inside this circuit is coming from resources on the circuit. If I open that feeder breaker at that time, I didn't change anything on the circuit, and the circuit can't necessarily tell that it got isolated from the grid. That is called unintentional islanding. And generally, we don't want that to happen, because now the utility does not have control of voltage and frequency. There can be some safety issues. So that's something that we need to prevent. I need to point out, and you notice it says this on the slide, this is a very low probability event. There's a number of stars that have to align all at the same time for something like this to happen. It's not impossible, but it's very, very rare. So how do we deal with this today? Well, the main solution is that inverters have built-in methods to be able to get rid of this, which we refer to as inverter resident active anti-islanding. Big highfalutin word that basically means what the inverters are doing is they're always taking the grid and just kind of going like this, just shaking it just a little bit to see if they can move it. If they can, the inverters say, whoa, I should not be able to do that, and they will drop offline. This inverter resident active anti-islanding actually works really well in detecting unintentional islands. It does work when you have many inverters on the circuit. It also works when I use the grid support functions that I was talking about before that solve some of these other issues. The anti-islanding does still work when I turn those things on. We're starting to become a little concerned as the number of DERs gets really high. Now, remember I said these DERs are always taking the grid and kind of going like this. What if I have a situation where, say, half of my power is coming from DERs? and all the DERs are going like this, might there be a situation where they actually could start shaking the grid when they're still not islanded? So eventually, we want to try to get away from this. It's a solution that works really well at lower penetration levels, but ultimately, we're going to want to do something different. We are now working toward wide area communications-based approaches that ultimately will give all of the DERs situational awareness of what's going on at the system level that they will then use to know whether they're islanded or not, and they won't have to shake the grid anymore. So, obviously they're expensive because there's communications involved, but that's something that's being worked on actively right now. Many utilities also are involved in the push toward moving something like that. The last thing that I want to show you here is this issue of DERs and bulk system dynamics. Many of you are probably familiar with this event that occurred called the Blue Cut Fire that happened out in California. Now, just a word of caution, most of what I'm showing you here is not DER. It actually was connected at the transmission level. But the principle is exactly the same, that there was a system level event where the DERs should have ridden through. They should have stayed online, but they didn't. And you can see this top chart here shows I'm sorry, these charts overlap with each other. They were supposed to be animated, but since I'm not in slide presentation view, you can't see that. Things were cruising along fine. Looks like it's a nice sunny day. Right here, where the circle 1 is where the event happened. It was a fault of a transmission line that led to a blip in the voltage. When that happened, over 1,000 megawatts of PV plants tripped offline when they were not supposed to, and you can see it in the PV production there. Then when that happened, this chart over here is a chart that's showing the frequency of the normally 60 hertz system. Now, you see there's a big dip in the frequency here. That's what we expect when we lose a lot of generation. When a whole bunch of our sources trip offline, the system frequency starts to fall. And if the system frequency falls too far or too fast, then we can start getting the system coming apart and we get a cascade problem. That did not happen here. Fortunately, we did not have a lot of cascading issues, but you can see that the precursor for that existed here. So there was a negative impact on the system because these things did not stay online when we wanted them to. What 1547-2018 tells us to do, and I apologize with this chart, this is a total eye chart, but this is the one that's in the standard, so I wanted to show you exactly what was there. What the standard defines now that's different from what happened in the past is that there are ranges of frequency here where it used to be if the frequency got down that low, we told the DERs to say, look, something's wrong with the system, get out of here and let us fix it. So that's what they did. Now we're saying, no, wait a minute. When those things happen, we need you to stay online longer. And you can see that now systems are required to stay online for many tens of seconds at very low frequency levels, which was never the case before. There's another thing that's a subtle difference in 1547-2018 versus the 2003 version. You see this green area here. In 1547-2003, there was no requirement for a DER to stay online ever. You could trip anytime you wanted to. So in other words, if I was required to trip at a certain frequency, I could trip faster than that to make sure that I got off by the required frequency. 1547-2018 did away with that. They said, no, there's a frequency band in here where you have to stay on. So that's a new feature. And again, it's all geared toward trying to balance the needs of the local system with the needs of the bulk system. So that's the end of my prepared remarks. Sorry, I went a little bit longer than I intended to, but wanted to make sure we left a little bit of time for questions. And you see my email address is on here, so I'm definitely willing to answer questions after the fact if anybody wishes. Thank you, Commissioner, and I would take any questions at this time.
Thank you so much, Dr. Rope. That was really fascinating. And we do have some questions. Let me get to the first one that came in on this subject from Tayoko Sajewicz. What is really high penetration levels?
Oh, excellent question. So what I would say normally is if your DERs are less than 10% of the load, they disappear into the variability of the load. No problem there at all. If your DERs are higher than 50% of the load, now we start to see impacts that we have to deal with. So over 50% definitely is getting to high penetration. There's a huge gray area in between there where you do start to see effects, but it's, you know, it's moving toward high penetration. So there's a spectrum there.
Okay, thanks very much. Let's see, here's a question from Steve Reimsha. As distributed penetration increases further, doesn't this very minimal islanding risk you highlight go away, similar to low penetration?
That's a really good question. I would say in general, when we get to higher penetration levels, what we need to do is to use some of these, you know, system level communications types of approaches to make sure that islanding is not even a question. The DERs have system level situational awareness, so the problem doesn't even occur. It's a very low probability event in any case. As Steve, you know, there's a number of stars and planets that have to align for an unintentional island to be stable at all. But usually we can't rely on low probability to prevent something like this. And that's why we take active measures. The big key is we don't want to keep doing the things that destabilize the grid. So as we get more and more of these out there, we need a new approach, and we're working on that now.
Great, thanks. Okay, now there's a question from Arthur O'Donnell. Mike, can you please explain the difference between 1547-2018 and 1547.1.2020? What does each do and require?
Gotcha. Thank you for that question. Yeah, I'm sorry, I kind of glossed that point over. So the short answer, I'll try to make this a short answer, is 1547-2018. Thank you. 1547-2018 sets the interconnection requirements. These are the things you have to do to be able to say that you're, you know, compliant with the standard. 1547.1 lays out all of the tests so that you test your equipment and know that it complies with 1547. So you have the requirement standard and the testing standard.
Okay. Well, that's great. Well, that looks like all the questions for you, Dr. Rope, and we do have a few minutes if people want to. We've got 3 minutes. I can go back and pick up some of the previous questions that we weren't able to get. Let me see where we were. I think we were, here's one. Let's see, wait. Sorry, guys, my screen changed.
Oh, sorry, I turned the screen share off.
Oh, okay. Okay, here's one from Adam Harper from OE Solar. Storage has an that's an answer. Let's see. Storage has an instantaneous demand response to all connected loads when the grid is stressed. That was an answer to someone else. Here we go. Lance Adkins asks to the presenters, and I think this is the previous panel, do you provide open access transmission service to others? And if so, are you charging or looking to include DG system capacity in charges to wholesale transmission customers? Anybody from the previous panel like to answer that question? It's in the chat. It's from Lance Adkins. Any takers?
Commissioner, this is Ruth Faggia. I'm not sure if this quite answers Lance's question, but I'm wondering if Order 2222 is going to partially be the answer. And if that's the case, I would say that there's a lot of work going on at the SPP, and there will also need to be some interplay probably here at the New Mexico Commission. But I'm not doing a whole lot of work on that, so I can't speak too much more, but I suspect that's something that will address Lance's question.
Okay, fine. Thanks very much, Lance. I hope that helps. If anybody else wants to chime in, you can also do that on chat. So here's a question from Stephen Reimsha again. Again, to the last panel, can you please further explain the rules not allowing export to transmission, and where does this get addressed? Can PNM provide further clarity on thermal stability concern limitations? And then he has a comment. I'm surprised that you would have thermal issues on these closed feeders. Are there also very large community or merchant? So PNM, is it possible for one of you guys to address that question?
Sure, I can try and explain in terms of the thermal stability. Typically when we see that there's too much PV generation on the feeder is when we start to see that thermal overload. To include high voltage, that thermal overload occurs when we have the amount of PV generation in excess of what the circuit allows, and that's where we start exceeding that thermal rating that we had kind of talked about. In terms of those closed feeders, we do have large interconnecting systems on those feeders that, like I said, did come through the application process for first come, first serve. So that is why those are at closed capacity.
Okay, great. Thanks very much. I appreciate it, Andrea. And we are at 11:01. We'll come back at 11:15, and for our best practices for interconnection rules panel. So take a break, folks. Thank you for being here, and I hope you come back.
Hi, Cynthia. This is Michelle. I'm going to present on the next panel. Is it okay if I just test my screen share now?
Sure, go right ahead.
Thank you.
Do you need me to tell you if it shows?
Yeah, that would be great. And if the slides advance, given the last panel.
Okay.
1 second.
Okay, I see Minnesota DER interconnection process. That's your first page.
Yeah,
right?
and yep. And do you see the disclaimer now?
Yes.
Okay, great. Thank you.
You're welcome. That's all you need. Great. Thanks.
Okay. This is Sky Stanfield. Can I do the same? And just
of course.
We work out.
Good idea. Yeah.
I need to warn you, I have kittens. They're new and they are attacking the screen this morning. So I'm trying to keep them out of the way.
You have what attacking the screen?
Kittens.
Oh.
We just adopted them and this one is just obsessed with this webinar. She's very into interconnection apparently.
I'm my kind of kitten, Michelle.
No, I think that's fine. It'll give us a little entertainment. Pretty slide.
First screen here, or my, and then does it advance?
What's that?
Did it advance?
Yes, now it advanced. Yes.
Great.
Just
okay.
now.
Thank you very much.
It's advancing. Okay, that's working. That's good. Okay, well, it's 11:15. I think we'll get started. This panel is best practices for using the interconnection rule and manual revisions. First up, we have Sky Stanfield. She's a partner at Shute, Mahaley, and Weinberger. And she's representing the Interstate Renewable Energy Council. So Sky, please let us know what's
Good
your
morning.
thoughts are.
Can you hear me?
Yep, we can. I can. I think you're fine.
Great. And can you see the slides? Thank you very much for inviting me to participate, and I'm happy to be here and was happy to get to listen to the earlier presentations today. The staff asked me to cover a little bit on the specific issues with respect to best practices, but also talk a little bit about how interconnection, some best practices with respect to how to approach an interconnection proceeding. So I'm going to jump into those topics. First, let me introduce my client, the Interstate Renewable Energy Council. IREC is a nonprofit that works to expand adoption of clean energy to benefit people, the economy, and the planet. We do that through participation in regulatory proceedings and providing advice directly to commissions and stakeholders across the United States. IREC does regulatory work, particularly on interconnection, on DER integration, grid modernization, energy storage, and now microgrids as well. And IREC also has a significant program regarding help building and train a quality clean energy workforce. And then we also focus a lot on consumer empowerment and ensuring that customers that want to install or get access to clean energy have the resources available. Of interconnection, we've participated in interconnection proceedings all over the United States. I think I've touched on something like 25 or 30 states at this point. So we've seen a little bit of everything. And what IREC produces every year or every couple of years, a set of model interconnection procedures. And these procedures are designed as sort of a guide for states that are looking to update their procedures. And what we try to do in each update is to incorporate emerging and existing best practices that we've seen in the many states that we've been working in. The model procedures are specifically designed for state interconnection. We also have worked with and recommend that states look at the FERC small generator interconnection procedures, or FERC SGIP, and that can also be used as a starting point. But where the FERC SGIP and IREC's model rules differ is that in each annual update, we really focus on some of the practices that don't often get incorporated into the FERC SGIP because they're not used as much for really small scale rooftop DG. And then they're also just we also update them more often so they capture some of the more emerging issues. We recommend that states look to the IREC model rules as a starting point for sort of a baseline of what are considered to be best practices nationally, but not to consider it a ceiling. And this is especially true these days as the technologies are moving faster and states are getting very serious about achieving 100% or high amounts of clean energy on their systems. Interconnection's evolving really rapidly and states need to continue to evolve and iterate. So the model rules are a good place to start a conversation as the end point. As I noted, there's a number of practices in the IREC model rules that are new and not included in the FERC SGIP that really help focus on the process for getting lots of small systems interconnected in an efficient manner. The other thing I want to note, and especially because we've been talking already today a lot about the adoption of 1547 2018, the importance of distinguishing between interconnection procedures and the technical standards like 1547. and also technical requirements documents that utilities may adopt, or in some cases, as Michelle will talk about, states may adopt. The IREC model rules and FERC SGIP are interconnection procedures. They contain some technical requirements and usually require cohesion with 1547, either the earlier version or hopefully the future version or the more current version, but they don't contain all of the technical requirements that may be at issue. So going to the sort of topic about how do you go about this process, we've heard pretty widespread support today for reopening a look at interconnection guidelines in New Mexico and discussion. So IREC's participated in working groups of every sort across the country, and I've got a couple sort of recommendations for the commission to consider about how to ensure a fair and efficient process that also builds a strong record for decision making. The first one is to decide on a starting point. Decide what document you're going to start with. Is it the current rules? Or are you going to be looking to a variety of different model rules? What do you want to be using as the guide for where you're the document that you're sort of looking to update? And then convening a working group or workshop process that is open to as many stakeholders as want to participate. I think the important thing in the beginning is to convene conversations where parties get a chance to understand each other's goals and the issues in a way that we find that often if parties come in, they have a clear sense of maybe what they want, but there's a lot of value to getting some conversation going between the utilities and the DER community and other stakeholders so that they have a common set of understanding of what everybody wants to accomplish in the process. And a facilitator can help sort of bring that dialogue along. And then rather than asking parties to come with immediately, very concrete recommendations, we think that initial dialogue about what the goals are and understanding each other's concerns, and then asking parties to present specific recommendations helps kind of refine those recommendations to be better from when you first present them. The other thing that is really important is obviously trying to structure it so that you're working towards consensus and that are important. One is to make sure that all parties are participating fairly with that goal in mind. I know that that's easier said than done, but I think the commission can play a really important role in making sure that all parties, and especially the utilities, are showing up with a good faith effort to engage with each other's ideas. And rather than just shooting them down and saying, we don't like that, trying to get parties to structure things so they come with counter proposals that help to work towards common goals. And then one thing that we see sometimes that happens is the working group process goes along quite well, but there's not a lot of follow through into whatever the formal adoption process is. And so what you want to avoid is having to create a whole new record once you get to the commission in the formal rulemaking stages. So ensuring that there's a quality working group report and ideally some staff participation during the working group process so that the commissioners don't have to sort of come into this proceeding where all the parties have already gotten a common understanding, but the commission itself wasn't part of those conversations. So if you can structure a process where you enable the commission staff to be involved, at least that helps with the follow through into the formal rulemaking. And then finally, don't force consensus. Rather, try to achieve consensus, but be sure to document alternate proposals that don't reach consensus and ensure that parties aren't being forced to agree to things, but rather that you're developing a record of the areas of agreement and the areas of disagreement. Okay, so now I'm going to dive into just a couple of the high of the issues you may want to consider. There's a whole lot more. I didn't have time in our presentation to go through all the types of topics you'll want to cover. So in the interconnection rules, in almost every state in the country has a set of initial review screens that use either 15% of peak load and or 100% of minimum load, or in Hawaii, they've done some effort to move towards 250% of minimum load, although that requires a lot of additional discussion to fully explain. What we're hearing in New Mexico is that the utilities are they both have these screens initial screens in place, but they're all leaders. And what's not clear to me is whether or how that's interacting appropriately with the idea of screening and then eventually studying projects that need to be studied as penetration gets higher. It's important to remember that while these screens, particularly the 100% of minimum load screen, which is now commonly used across the country in supplemental review, is an important technical screen, it doesn't mean that when a project, if generation exceeds the load, that there is not a definitive determination of whether there's a need for upgrades. Rather, it's a determination of the need to study. It is possible to have backfeed on the system. And so we don't want to set that as a hard and fast limit on the amount of capacity that can be installed, but rather as a threshold for further evaluation. I put on here that a circuit should never be closed. You do have a point where upgrades need to happen. And so there's an effective closure until upgrades can be done. But there always should be an option for projects to upgrade the circuit where issues have been identified. And that gets me to the next point, which is ultimately grids are going to need to be upgraded. If we're going to seek high levels of DER penetration, high levels of electric vehicle and building electrification, we need to accept that upgrades are an inevitable part of the interconnection process. Historically, we've mostly focused on what I showed on the map here on the left, which is trying to find locations where there is capacity, and that is still very important. But I think we also need to move towards adopting policies that enable those upgrades to get done, because ultimately there's only going to be so much available capacity on the system, and we're going to need to upgrade. So I think both focusing on making sure that the initial screening and the evaluation is appropriate, not being overly conservative, but also building processes that enable those circuits to ultimately be upgraded. And then the last thing I just want to highlight, you guys have already talked a lot about 1547-2018 adoption, and I think it's great that you're moving in that direction. IREC has a number of important resources that you might find helpful on 1547 adoption. Michelle will talk a little bit more about the process we went through in Minnesota to make that happen, and we've also been involved in all the other states that are working on this. When it comes to energy storage, I want to highlight that the single most important thing when it comes to energy storage and using it in the ways that people have been discussing somewhat today is defining and allowing for the concept of non-exporting systems and also limited exporting systems. Most rules in the country don't even contain anything regarding the process for installing a quote non-exporting system, but very few have a rule regarding limited export systems. And that is one of the things that is the biggest focus point for really enabling the integration and positive utilization of energy storage. And what that comes down to is both modifying the screening processes to recognize the difference between a project's nameplate capacity and the amount it actually plans to export onto the grid, and then the control technologies that will be utilized. In particular, it's when we're talking about small scale systems especially, it's important to recognize and enable the use of power control systems and identify the review process that they will go through. There's obviously a number of additional issues that you'll probably want to counter, but those seem like the big ones that people are talking about. And IREC has a number of resources, and we'll try to be engaged in helping to point parties to those throughout this process. And with that, I'm going to go ahead and turn it over to, or back to the commissioner. Thank you.
Thank you very much, Skye. That was quite interesting. Okay, so next is Michelle Rosier. She's a distributed energy resource specialist at the Minnesota Public Regulation Commission. And Minnesota always gets their rules done before everybody else, it seems like. So I imagine Michelle is part in that. Anyhow, Michelle, please proceed.
Thank you, and thank you for having me. Okay, so sorry, I was getting a little feedback there. My name is Michelle Rozier. I'm the Distributed Energy Resource Specialist for the Minnesota Commission. And I just want to say up front the disclaimer that the ideas expressed here are my own and that our commission, like all commissions, speaks through its orders. So I was able to listen to most of today's discussion, and I thought it would be useful to just provide some context for Minnesota's situation, which is different than New Mexico's and other states. But in Minnesota, we have just over 1 gigawatt of DER capacity connected to our grid. And that's in just over 9,000 distributed energy resource systems. So I know you have a lot more systems connected, but a smaller amount, I believe, of capacity, or I didn't add up between all the utilities. And that's in part, I'll show you why, but on this slide, what you can see is our cumulative capacity. And in these later years, all of the blue colors are related to solar. So most of the DERs connected are solar in Minnesota and have come on in the past 4 or 5 years. So here you see the number of annual interconnections that are joining our system. And this top line is the smaller 10 kW and under, which are usually residential or small commercial rooftop units. And then the other line of note is this kind of maroonish brown line that seems to drastically increase beginning in 2016 through 2019. And that is for systems that are over 40 kW, but under 1 megawatt. And that increase is almost entirely driven by Minnesota's Community Solar Garden program. And so that's one utility that has, more utilities have them now, but I would say, I believe it's over 700 megawatts of community solar gardens with one utility, and is the major contributor to that line. So I'm going to spend most of my time today talking about our process of updating the interconnection standards and what things changed as a result of that update. This is the high level of our commission order that initiated that update. And you've heard many of these terms today, but we convened a work group and it involved a number of players, but it's the Distributed Generation Work Group. We selected a facilitator to develop our record, and then we used as our base document the FERC SGIP and SGIA. And this commission order was due to a petition by parties to update our interconnection standards. And so I'll walk over how we dealt with the feedback we got prior to launching our work group. In the order, the commission envisioned 2 phases of an update. The first one would address the process and agreement, and the second one would look at the technical requirements. And the order set a general time frame for going through that update. So here you see the different phases that I just mentioned and when they went into effect. So we first updated the process, the application, and the agreements, and that went into effect June 17th, 2019. The second phase was to update to the technical interconnection and interoperability requirements consistent with IEEE 1547-2018, and that went into effect July 1st, 2020. And then in the process of going through these 2 updates, we were petitioned and the commission granted looking at the final remaining piece of our 2004 standards, which was an attachment related to DG rate guidance. And with the FERC PURPO Reform Order 872 and a number of issues emerging in compensation around DG, this is an open comment period that the commission is looking at. And one thing I wanted to note is through this process, the commission identified that there needs to be some sort of change management type process where we're ongoing evaluating how the interconnection standards are working. So in 2004, we adopted them. We didn't have a lot of systems interconnecting. The technologies were still pretty new. That's not the case anymore. And we've seen how it's very easy for a state to get behind what's happening with their standards. And so we set up a ongoing distributed generation work group that meets annually or more frequently as needed. And they're tasked with reviewing implementation and technical issues that arise with the MNDIP, the MNDIA, our technical requirements, or emerging DER technology. And just for some perspective, when we rolled out our new interconnection standards, we required temporary reporting on a number of the provisions so we could understand how the standards were working and if they were sufficient, and then convened this work group to evaluate those results. And we met the reporting came in March, and we met last year and have kind of met continuously since. So there's been a number of issues that have needed to be addressed. None have yet led to changes to the statewide standard. Oftentimes they're related to the utility business practice of implementing that standard, but just a recognition that that ongoing review has been needed. I'm not going to go through too many of the details here, but I just wanted to provide kind of how the process worked for us, and also recognize the distributed generation work group. The commission actually set the lead participants and then allowed open observation and public engagement. And from our perspective, that was important to create an expectation that the lead participants would see the process through to the end, rather than kind of ebbing and flowing based on individual interests. And that was important for recognizing that someone asked me about the MNDIP and whether everyone agreed on a certain element. And I said, you know, they agreed on the whole, and people gave and took in different areas. And so having that set of lead participants work through how it all fits together was important to moving forward and getting an update, rather than fight about every single aspect of the standards. Again, I won't go through all these details, but they're in the slides that you can look at. This is the agenda for each of the phases, the issues that we addressed, and the timeline that we went through. Excuse me. So we did not require consensus with the work group. We encouraged agreements, and where people didn't agree, we asked that they just help us develop the record so that the commissioners understood the trade-offs, and then left it to the commissioners to make the determination. And I wanted to just point out, a lot of updating your technical or your interconnection standards will be very technical. And really the work group will be able to work them out, because it's just kind of updating from whenever you last updated. But there are policy considerations baked in, and it's important to recognize those up front, and maybe, you know, not get too tied around the axle in trying to fight out policy decisions that really the commissioners are going to probably need to determine, rather just understand them. And so a couple of examples of what came up for us in our process was how to treat storage applications and their capacity. So we uncovered that there's a trade-off between the hosting capacity of the utility in terms of how many they will approve of these storage systems on their feeder without upgrades, versus the customer flexibility concept of being able to change how your storage performs. And now there's a lot of flexibility that doesn't change the hosting capacity, but the issue there was this idea, I think Sky mentioned it, of like, are you studying that worst case full nameplate rating versus are you considering that how it's actually going to be used? So we worked through those details. This has been a little bit less of an issue here, but I know in Minnesota, but I know in other states, net metering integrity issues, like this idea of whether you're going to allow your storage to contribute to your net metering program and potentially export to the grid. And then I was really surprised at how much time we spent locking down that capacity definition. But as Sky mentioned, it is important to work through the differences of what is the nameplate or installed capacity versus the capacity that is limited or non-exporting. And so that concept is in the FERC SGIP and SGIA, but it's something we spent a lot of time working through to build shared understanding of how that should work. And one of the biggest kind of hanging where we got hung up was around how load is treated in that determination of capacity. Interconnection requirements and how costs are recovered. So in Minnesota, we have a cost causer pays principle. And so in requiring production meters or the disconnect switch, those are additional costs to the customer. And then more recently, this has come up with the distribution upgrades that are required. And I know different states have used other methods of cost recovery. Insurance, and then how legacy equipment is treated when agreements are updated, were all other policy considerations we work through. So some of the changes that are from going from 2004 to the MNDIP, which went into effect in 2019, is we now have pre-application reports where people can get information before they submit their interconnection application. We have a queue that assigns capacity and organizes how the applications will be reviewed, and that's transparent, includes publicly posting that queue when the utility has a certain number of applications. We have a simplified project process, recognizing smaller projects don't need the same level of review and can proceed faster. We have a fast track option, and we updated our engineering screens based on the updated technical analysis of expert organizations. And that was, we took the SGIP screens and updated them since FERC last updated the SGIP. We also looked at clarifying what constitutes a major modification and when a new application would be required. And this is a way to sort of keep that queue moving and not have too many changes in the process. And we also identified what isn't a major modification to avoid kicking projects out unnecessarily. A big one was setting of the timeframes, both for the utility and the customer, and giving the option to withdraw an application for failure to meet those timeframes or requesting an extension. And that's on the customer timeframes. The utilities are supposed to provide notification when they're not going to miss their timeframes, but there isn't another penalty in the MNDIP for the utility missing the timeframes, but they are expected to report on their performance, and the commission monitors that performance. We also allowed electronic submission for applications and materials, and we enabled the signature and payment because, again, these are statewide standards. And so some of our smaller utilities don't have that technology and don't have the number of applications where it's an issue, but they all must accept electronic submission of the application. These are a number of other improvements I won't read through. The last one I want to mention on here is the application agent. We clearly identified when someone other than the customer is going to manage the application. That's often the solar developer and installer. So this is a visual of how our process is supposed to work. And one of the things I'll note, I think I heard it come up in one of your utilities explanations this morning, but our process envisions the customer waiting to install until after they have been fully aware through the studies of what the costs are from the distribution level, like if they need distribution upgrades. That doesn't always work in practice. And so a number of complaints we've seen are customers who went forward installing and maybe even starting to pay for their system before they got those results, and then being surprised when they get hit with a transformer, which might be $5,000 to $15,000. The technical requirements, I'm going to shorten it because I realize I'm running out of time, but we went through 1547, 2018, and what you heard from Dr. Roop about there are decisions that you need to make as a commission. We made those decisions in our statewide document. We recognize that we can't implement them until the certified equipment is available. So we have an interim implementation step. We're waiting for that certified equipment, which is expected later this year or early 2022. And one of the things we also recognized is that our technical requirements are statewide, but as we get towards these advanced inverters and towards systems wanting to enable newer technology, but recognize not all grids are ready for that, we allow utility technical specification manuals to address the utility specific needs. And then lastly, I'll just close. I've told you a lot about the substance of what is in our MINDIP, but in how we put it together, I just would say as you move forward, identifying a well-balanced work group of individuals that represent the utilities, the DER industry, and consumer advocates will ensure you have all the perspectives at the table in the discussion. Establishing a clear process, and that's both the scope of what's in front of you and the time frame that you're going to work through it, and grounding that process in guiding principles and facts will help you not get stuck and kind of get to the end. Encouraging shared learning and including the commission in the process. No one individual in this process has the full story, and that's one of the wonderful things about our work group is that people were learning from one another, and we've now been out presenting what we've learned to others. So like it's a shared understanding that people can learn from. Keep in mind, if you are future-proofing your interconnection standards versus if you have a specific outcome that you need to address right now, that might change how you work through things. Engage outside expertise in a transparent way. You're obviously doing that with today's workshop. And then, as I mentioned earlier, delineating when it's a interconnection or technical issue versus a policy consideration to just buy yourself a way out of some of those really complicated policy questions and focus on the updating what you can pretty easily versus what needs policy considerations. And then last, these are just some links to our resources if you want to learn more about our process. Thanks.
Thank you so much, Michelle. That was really, really informative. I'm certainly learning as we go along. So next we have Ken Wilson, an engineering fellow, pardon me, at Western Resource Advocate. Take it away, Ken.
Thank you. Thank you, Commissioner. I did not prepare slides, kind of batting cleanup. I thought I would address issues that have come up during the conversations this morning. I am an electrical engineer with 45 years of experience in telecom and energy. I was at Bell Labs for 20 years, and for the last 10 years, I've been working with Western Resource Advocates. We advocate for good renewable energy in the Intermountain West. As part of my job, I worked with the Arizona Commission and parties in Arizona on interconnection rules. I also am currently still working in Colorado to finalize new rules. And I've also assisted with rule changes in Nevada and Utah. I would like to focus for a minute on Arizona in particular. In Arizona, we really started from scratch. They had no commission approved rules. And about 4 or 5 years ago, we started developing a set of rules. We looked at IREC's excellent model rules. We looked at the FERC SGIP, and we also looked at California's rules and tried to come up with a set of rules that would work for a smaller state. And here I want to caution how closely you look at California, because California has a huge commission staff. They have huge utilities, lots of interested parties, and their rules, for example, are about 100 pages long. What we developed in Arizona, looking at those rules, is about 50 pages. so about half the detail. And Colorado's rules are maybe about 30 pages. So the level of detail that you want to get into is kind of defined by the amount of resources that everybody can put on it. So I would suggest looking at California, but look more at Arizona and then Colorado as examples of rules that smaller states might think about. So let me then address a couple of issues that have come up in the last couple of hours. And this was mentioned both by Sky and by Michelle, and that's the capacity of a hybrid system that has both storage and PV. And this is an issue for the following. Let me give you an example. Say you have a customer that wants to put up a 10 kilowatt photovoltaic system and also an integrated 10 kilowatt battery system. So what's the capacity of that? Is it 10 kilowatts or is it 20 kilowatts or something in between? And this gets to another issue that was mentioned earlier, and that is how do we define a battery system? And there are really three choices: an exporting system, a non-exporting system, and then what's called an inadvertent exporting system, where there may be brief periods where the battery does export, but it's so brief that we don't need to be too concerned about it. And so the rules that you develop should go into some detail on defining these different battery storage systems and defining the capacity of the total system so that the utility can then look at how to best consider that capacity in terms of the technical screens, because it would be unfair to take battery storage plus PV system as a 20 kilowatt system when it really will maximally export 10 kilowatts. And so that's where the real rubber meets the road with respect to these integrated systems. And you can get a lot of, I think, interesting information on how to do that from the Arizona rules. And then if you want a lot of detail, look at what California's doing. And I believe Commissioner Fishman was very interested in this issue. And if people would like additional detail, I'd be happy to provide it later. The next issue is how aggressive to be on the screening of systems, the technical screens. And here, I tend to be a little bit cautious. Sky showed the 15% threshold and the 100% threshold, and then Hawaii that is really going all out because their energy cost is 3 times the energy cost in New Mexico. And so they're desperate for renewable energy and rooftop energy, but they have had problems and they are still kind of struggling with how to maximize the distributed generation that will go on their system. I would be cautious with that. I think look at other states like Minnesota, Arizona, and Colorado as to what they're doing. Again, the IREC model rules, I think, are an excellent place to start to look at some of these issues. The next issue that I wanted to say is IEEE 1547. You've heard a lot today, a very good presentation on using IEEE 1547. There are some points of dispute in how you implement the IEEE standard. The utilities will want more control, the solar parties will want less control, and somehow you have to find a balance in between those that works for the system being stable and not causing problems with its neighbors. One issue on process before I give us a little bit of time for questions. In Arizona and Colorado, we had very good workshops and discussions between the parties, and there was give and take, and we settled on, came to some agreements, almost like settlement discussions, but not quite. What you want, and that's a very good way to do it, and that's what Minnesota did, as Michelle discussed. What you want to avoid is after that process is done and there was give and take, that parties go behind the scenes and talk privately to commissioners and suggest amendments that were never discussed. And I think that makes the whole process of the discussion and negotiation seem like, why did we do this? Why didn't we just go to a disputed case in the first place? So I would be cautious about doing that. I don't know what the ex parte rules are in New Mexico, but sometimes rules don't have the same ex parte restrictions. And I would just caution commissioners to talk to staff, as was mentioned, that they did in Minnesota, to see where this all came out in the discussions and what the give and take was. So let me quit there and have a few minutes that everyone can ask questions. Thank you very much.
Thank you, Ken. I appreciate that. We are at 11:56, so we're, just slightly ahead of schedule, and that's good. Let's see, I haven't really seen questions come in concerning this panel, but that's fine, because what I'd like to do right now, before we start comments, is just for a few minutes, take an opportunity to listen to Arthur O'Donnell, who is working with our PRC as a Department of Energy fellow. Thank God we have him. He's quite a DER, a professional coming from California, but he will explain briefly what our stakeholder process will be going forward. And I wanted to do this before comments in case I lose people during the comments. So Arthur, would you mind stepping up now while we've got this time? And thanks so much, Ken, I appreciate it.
Thank you, Commissioner, and I'll share my screen now if everybody can tell me that they can see what we have here. First of all, I want to thank all the presenters today. This is exactly the kind of information that we were hoping to elicit in this workshop, and especially the last panel, which brought some very real world insights into what we can expect as we go forward. So thank you all very much, and we look forward to working with you. Just some things as outlined in the workshop notice and the notice of inquiry. The Commission is interested in getting written comments, and post-workshop comments are requested by March 5th. We had about 3 formal comments on the NOI document from PNM and some industry groups. If you can go back and look at the questions that were posed in the NOI and address them in your post-workshop comments, given what we heard today, that would be very beneficial to the record. Want to let you know that taking the advice of IREC and Minnesota and suggestions from other parties, we are going to be engaging a third-party facilitator, a group called GridWorks, which is a nonprofit organization that has worked in numerous states, Oregon, California, Hawaii. I believe that they also had some involvement in Minnesota. They will come on board to organize and manage this stakeholder process. And we're looking at really 3 discrete steps that build on each other. One is very basically to revise the interconnection rule, which is Title 17, to update the references. It still references the old FERC SGIP. It still references the very old IEEE standard. There are no provision for storage. things like that. And we hope that that is a relatively non-controversial element and gets everybody used to working with each other. Second is to align the rule with the interconnection manual. And that may take a little bit of time because the manual, as you know, is more of a process and application document. And that's where the screening processes are laid out. That's where the timelines are laid out. That's where the fee structure is laid out. And again, we want to make sure that we have good representation from all parts of the utilities and the industry and consumer representatives as they're available in order to hash those things out. Our intention is that then the working group will come to the commission with recommendations that the commission can act on in the proceeding, in a notice of proposed rulemaking proceeding, and we'll work out the details as to how that's, when and how that's going to happen. And finally, a little bit longer, because we've heard the importance of the technical standards, to determine what required capabilities for inverters ought to be per 1547-2018 et al., and to begin addressing the longer term issues of interoperability and control issues that will necessarily lead to policy decisions. We hope very much to get at least the first two portions of this, the changes to the rule and the interconnection manual, done this calendar year, right? Earlier the better, but you know, we'll wait until the process gets underway, and then to work on the actual technical standards later on. I mean, we may actually have the commission start requiring 1547-2018 in inverters, but to actually work out all the details later, and we'll require your input. So what I'll suggest is please volunteer, talk to your constituents, talk to your members, talk to your engineers, and we would really like to have a dedicated group of people who can work on this in a stakeholder process. And you can send your nominations or volunteers or requests as part of the post-workshop comments in this docket due March 5th. And that's all I have to say. Commissioner, thank you very much for the opportunity.
Arthur, one question. Who did you say to send the comments to? I didn't hear what you said.
In the docket, right? For the comments are posed. I don't have the NOI in front of me, but there's a process for filing comments in the docket.
They can do that. They can email my office if they can't figure out how to just put it, you know, send it straight to our docketing office. Either way, and we'll get them there. But I think that probably if you just sent, what's the name of the case? What's the number again? It's 21-131?
No, it's 171. And I think it's a 20. Yeah, it's
20-00131. 171. Okay, that's the number of the case. But if that's too burdensome, just email it to our office and we'll get it sent in. And I see Isaac Sullivan Leshin of our office, just put it in chats. That's the case number. And so you would have to email to our dockets office. So,
and we'll also be posting these presentations in that docket. So if anybody has trouble getting into the e-docket, you can contact the commissioner's office and they'll help you get through that.
Yeah. Wonderful. Thank you so much, Arthur. And so now I want to open it up to comments. And, you know, if you had a question in the chat, please feel free to raise that during comments. But I want to just focus on whoever has comments. And then if nobody does, then we'll go through chat questions. But I was told before the hearing, we began this morning that Jim Desjardins would have a question or a comment to make. Jim, are you around, or is some proxy available if you're not here?
Yes, Commissioner Hall, thank you very much. Yeah, well, first of all, thank you so much for putting this workshop on, and we've been hoping to have something like this for a long time, and so we're super appreciative, and we're appreciative to all the commissioners and presenters and everyone. And you know, just a little background. First of all, my name is Jim Desjardins. I represent the Renewable Energy Industry Association of New Mexico, and we've been around since 2004. And so we've been through actually the first interconnection manual, and been through quite a lot of things. And we have a homegrown industry that has about 2,000 people working in the renewable energy industry in New Mexico. Is one of the fastest growing industries and a real bright spot. But a concern that we have had is interconnection applications not being approved. And so again, we're just really happy that there's something in place to address that. And I'll just leave it at that. And I hear my phone ringing in the background, but thank you very much for putting this together.
Okay, all right. You're quite welcome, Jim. Who's next? Do we have any questions? What you could do is just speak up would be the simplest thing, or raise your hand if you want to. Steve, I see you there. Do you have any questions?
Well, actually, it's a little bit off topic, but I just wanted to welcome back Rico Gonzalez from EPE, if you hadn't done it earlier. But Rico, clearly they keep dragging you back. So anyway, it's just glad to see you back and involved.
Okay, so I think what I'd like to do then is go through whatever remaining questions there were in the chats. And there aren't any. Let's see, wait a minute. Question per panel. This is Lance Adkins. This may have been for a panel. He set the question right before noon, so I think it's prior to the most recent panel. No, it would be the most recent panel. Question for the panel. How should distributed generation system and size capacity limits be established for net metering systems? Who wants to jump on that? Ken? Sure.
I can answer that. This was a big question in Nevada. What they are doing is they have the customer certify that their battery storage system will not charge from the grid, that it will only charge from their PV system. And there are settings generally in these combined systems that can be set so that that occurs. In other words, the battery storage system would only be charged from the PV and not from the grid. And if it's set that way, then there should be no problem with net metering. So that's one way to do it.
Commissioner Hall, this is Michelle. One other thing to consider about capacity with net metering is that if you want to use some of the advanced inverter functions, some of them require headroom, which is to like hold back on the full amount that your system operates. And so you might want to put that into consideration in terms of like if you require net metering to size to the capacity, like how much annual consumption is used on site, but then you're asking them to hold back to do frequency response. So Minnesota hasn't addressed that yet, but that question did come up.
This is, I actually have a really different perspective than those two on what should be done here. And I think it's a policy question for the commission about whether you want to do those requirements through net metering rules or through interconnection. Metering is not really, in our view, an interconnection issue. It's a rates and revenue issue. It often is included in interconnection procedures, but it's important to distinguish between metering from a technical standpoint and metering from a rate standpoint. So I think before we presume that it will be addressed in the interconnection procedures, I think there's an initial question you need to ask. And then I want to point out that there are really complicated requirements going into place in a few states with respect to NEM integrity, as Ken was describing a second ago. There also is a lot of states do the behavior that parties are seeking to prevent. I don't think it's a non-issue, but I think there has again is an important policy question at the front end, which is how complicated of metering requirements you want to put into place in light of a questionable a good question about whether or not there's actually an incentive to do the behavior you're trying to prevent.
That's interesting, Sky. Thank you very much. I've got a question here, which asks, from Eric Martineau from GridWorks. He says, can we hear any answers to Steve Reimsch's earlier question, which is, can you please further explain the rules not allowing export to transmission, and where does this get addressed? We didn't get to this question, but it's important for scoping the further process. So I guess I missed it as a question. Anyhow, would any of you like to address that? Please further explain the rules not allowing export to
Commissioner
transmission.
Hall, this is Adam Alvarez with PNM. The rules would be outlined in our OAT process for wanting to export to the transmission. One issue, though, is without knowing where you want the energy to be exported to, you can't just automatically export your energy to there. You have to follow our OAT process, become an interconnection customer, and go through all the applications.
And this is Michelle. Oh, go ahead.
Sorry, this is Roberto Favela. Yeah, once you start exporting to the transmission system, it falls under the FERC jurisdiction realm. So it will be, the party can still interconnect, but it will have to be interconnect under the federal guidelines.
I think that's a really important legal question the commission's going to have to dive into. I think those answers, other states have come to very different conclusions about simply exporting to the transmission system does not impart FERC jurisdiction under my understanding of the rules, and especially under Order 22.
And this is Michelle from the Minnesota Commission. Maybe I'll just offer.
So there are lots of.
Oh, sorry, I was just going to offer as like our perspective. So distributed energy resources are not intended to go onto the transmission system. That's what we do the engineering review around, is to make sure that that doesn't happen, unless it's intended, in which case that's a different thing for our interconnection process. To the extent it is, there's an affected system study that is triggered where you do additional review. For us, we have an ISO, so we would engage them in doing that review to make sure there's not reliability concerns. And all of this is assuming no FERC Order 2222. We're working on how to address our interconnection standards given that potential.
And this is Adam. I'd like to just clarify. Order 2222 only applies to the RTOs and ISOs. PNM is not part of an RTO or ISO, and there's no rule that we need to follow at this time.
Just Ken Wilson, just one quick comment. There are two different issues here. One is if you have a particular generator that wants to export into transmission, then you get into the whole other interconnection process. But if you have an aggregate of distributed generation, say on one substation, there's so much generation that it could export up to transmission, that's a whole different issue. That does not require any FERC approval or anything. It's a decision that utilities and commissions need to make. Should they allow that? Now, generally, the screens that are used to approve interconnection will prevent that because they're set to not allow backfeed to flow that far. But you could decide that you want to allow that. That's, Hawaii's doing a fair amount of that already. But, that's a very interesting and serious question that would need to be discussed further.
Ken, this is Arthur. Can I ask you to just clarify how we asked that question? And is this a policy question rather than an interconnection question?
Well, it's how you set those screens. Like if you went to the 250% that Hawaii is playing with, you could get export through the substation into transmission, that's possible. If you stick with the 15% and the 100%, it's very, very doubtful you would. So that's the simple answer of how that's dealt with. But one thing I heard, I think the gentleman from the REA saying is that their contract in buying power from one of the other providers doesn't allow them to inject energy back on the transmission grid. That's a whole different legal question. And I think I heard that earlier today. And that may be what the gentleman was really asking about is where is that set? And it's probably the contract between the REA buying power from the larger utility that's selling power.
Ken, I have a question for you. Oh, go ahead, Roberto. Go ahead, Roberto.
I just like to make the comment that I mean, I think the workshop is very important for us to stay on the technical and procedural parts of the rule. The transmission exporting has a lot of intricate details, and FERC 2222, I mean, how the state and how it applies to the different utilities, it will have a big impact on that decision. So I think the first thing that needs to be decided is how FERC 2222 is going to impact the New Mexico utilities. That was primarily meant for RTOs. I mean, the FERC 2222, the process. So I think once that is defined as to how that's going to apply to PNM, EPE, and the other entities that are not part of an RTO, then that's going to define also what's going to happen and how it's going to take place as to what's under the jurisdiction of the state interconnection or under the federal interconnection. So,
it's a good observation. That's interesting. I have a question for you, Ken. Why would a commission not allow that kind of aggregation directly onto the grid, onto the transmission system?
Well, thank you. It depends on, I think there's some risk there. A lot of substations are not set up to deal with backfeed. They would have to go in and make a bunch of adjustments in the substation and maybe other places. Because when you start getting backfeed, you know, normally the distribution grid is not set up for that. If they see energy coming back to the substation, how do they distinguish that from, say, lightning? You know, a lightning strike, they want to shut things down and not let it burn out things. And so if you get enough distributed generation to backfeed energy into the substation, sometimes the regulation there, the equipment is not set up to recognize the difference between that and lightning, for example. Thank you.
Okay. So we have some more questions. Let's see. And I'm glad somebody pointed that one out to me because above it is another question from Lance Adkins. And this is a question for the presenters. Do you provide open access transmission service to others? And if so, are you charging or oh wait, did I just read that? I think I did.
Yes, we addressed that one earlier.
Yeah, okay, fine. Okay, great. Okay, I did that. Okay. Okay, oh, here's one from Mark Geiser from at MNERD, Energy, Minerals, and Natural Resource Department. He says ECMD, sorry, I don't know what that stands for, has been supporting a school interconnection in the SPS XL territory. Oh, it's a cooperative or a utility. The capacity of the system is desired to be 5 megawatts. SPS has claimed that interconnection of the system will take 3 to 5 years because of the studies required by the Southwest Power Pool. That's the RTO that SPS belongs to. Although this is an extreme case outside of the New Mexico interconnection rules, are there PRC inputs to SPP to smooth the adding of systems of this size that require ISO RTO support? Well, I don't know the answer to that. I don't know if anybody is on from our agency that can answer that. And I'm not sure, Mark, are you still present? I'm not sure what you mean by inputs. What there is a, I see you, Mark. Do you mean?
Yes, I'm.
Hi. You want to elaborate what you mean by inputs? Because all I have to offer, from my knowledge, is that one of our commissioners, Jefferson Byrd, is a member of the, what's it called? Of the, well, there's a committee of commissioners. The name of it will come to me in a minute. Of all the states that are members of the RTO, of the Southwest Power Pool. And Jefferson is a member of that. So through that membership committee, through his membership on that committee, he could be a voice on this issue with the RTO management, but that would be, you know, a pretty informal methodology. When you talk about inputs, what are you talking about? More than a procedural type of input like that?
I was looking at it in terms of procedural, but you know, I kind of addressed it here in this last discussion about the FERC 2222 and the backfeed onto the transmission. I mean, that's where that question lies, and how we have at the New Mexico PRC level, do we have ways that we can influence, make faster decisions for that RTO connection, or is it just limited to their process? And that was kind of like the question, is that, you know, and oh, by the way, when we do the interconnect manual updates, we should consider these externalities also. So,
Commissioner
I think
Hall.
you're right. I'm sorry. What's up? Who's that now?
Sorry, it's Michelle from Minnesota. I was just going to say what you're speaking to is the affected system study for us in our interconnection requirements. And we acknowledged when it's based on the FERC SGIP, we acknowledge that we don't have control over our ISO's review process, but we also acknowledge that we maintain jurisdiction over that DER. And so it's a coordination. It's not handing off to the ISO, but it's a coordination. And we expect our utilities and, if necessary, our commission to engage. And we've been working on better outlining what those affected system studies might look like. We haven't needed them yet, but we acknowledge that we may in the future, and figuring out what they look like while maintaining the commission's jurisdiction.
So Michelle, the magic words I heard you say was, we expect the utility to engage. You mean as they're, insofar as they're a member of the RTO, they could raise that with the RTO management or appropriate committee or whatever. I mean, I've sat through a lot of their meetings. I know they have, it's pretty process oriented.
Correct. So our interconnection standards acknowledge that the utility and the customer will work together to move through that affected system study with the ISO. And so there is some engagement by the utility to make sure it's moving forward, because our interconnection standards hold responsible the utility and the interconnection customer. Our standards don't impact what the ISO does. So you have to coordinate with them.
Yeah. Thanks. So, Mark, does that help you? That sounds like a bad situation, frankly.
well, I mean, it's to illustrate that these sort of questions are already appearing in New Mexico, and you know, as we have in front of the legislature right now, we have community solar bill that talks about 5 megawatt community solar installations, and obviously, if we have an RTO being the provider for co-ops, that becomes an issue if it takes 3 to 5 years to put a 5 megawatt community solar system into that co-op or system.
I agree. That's an issue. So I'm glad you brought that up, and I hope you're going to volunteer on our work group process.
I'll be around.
Good. Okay, let me see what else there is. Um, um, I'm not seeing a whole lot of other questions here, guys.
At the
Let's
very
see.
bottom, Sky has a question.
Oh, okay. And Tayoko had left a question, but he missed. He's left, but let me ask this in case anybody else wants to know about it. And this was made at 10:57, so I think it had to do with Dr. Ropp's presentation. And he was saying, I'm wanting more context. One of the screens in SGIP is 100% of minimum loads. Where does that level generally fall in the context of 50% of loads as high penetration? Dr. Ropp, are you still with us?
I am, if I can figure out how to unmute. There we are.
Do you want me to read it again?
Yeah, would you please?
Yes. He says, one of the screens in SGIP is 100% of minimum loads. Where does that level generally fall in the context of 50% of loads as high penetration?
Oh, I see. Yeah. So it's a little bit of an apples to oranges comparison there, as you might imagine. We're using some different bases. That 100% of minimum load is based on it, like it says there, the minimum load. That's supposed to be the point at which you start having the possibility of DERs beginning to export back upstream. And of course, most of the time, you're still going to have load considerably larger than that. So you still won't see export, but that's just the point at which you could begin to touch that. So, that is where additional studies and things like that might begin to kick in. So that's how that criterion got established. It's fairly conservative, but it's physically reasonable.
Okay. I'm going to call you later about that. That's interesting, but I want to visit with you offline. Unless anybody is aware of any other questions, I am not.
Sky Stanfield has asked
Oh,
whether
yes,
the
yes, yes.
utilities could
Skies.
speak as to whether they currently allow use of power control systems for energy storage systems. And I don't know if there's a utility person that can speak to that.
Sure. Could the utilities speak to whether they are currently allowing the use of power control systems for energy storage systems? Anybody in the utilities want to address that? I guess not. They may have left. Okay, well, do we have any other comments from anybody, folks? Any questions or comments?
I just have one. This is Jim Desjardins again with Renewable Energy Industry Association. So just one, I guess, comment just from the last question about how utilities look at storage. And what I'm being told is that they look at a battery as a generator. So that for example, if you have a 10 kW solar system and a 10 kW battery, you have 20 kW of generation. And that poses a challenge because for a number of reasons, but that is what I'm told we are experiencing.
So Jim, if I understand that correctly, it sounds like even if, so let's say a solar plus storage system is using a power control system to limit export, or so that the solar and the storage don't export at the same time, the utilities are still studying them as though they are both simultaneously exporting.
I'll be honest with you, I'm not aware enough of the situation to know if there's a power control system in there, but I've been told by a number of members that when they have put in applications that involve a battery, so for example, a SolarEdge inverter and a LG Chem 10 kW battery with an auto transformer, that they look at that, they add up both of those to come to the size of the system.
This is Michael Ropp, and that is consistent with what I have seen in my experience. Most of the time, utilities were required that the study be done according to the total rated nameplate capacity of what could be exported, just in a maximum sense.
Well, but that's the point of wanting to know whether they're allowing the use of power control systems or even relays or other things, because it's not necessary, and multiple states now are not requiring that. If you have adequate controls in place, and that's so that so that you can prove that the systems aren't simultaneously exporting. And that I think is something that the commission will need to dig into.
And if I just might add just a little bit more, we're anticipating, as are a lot of people are, that storage is going to be an integral component of a solar system in the future. And I think if you just look at what's going on right now and to the east of us, it just makes sense for a number of reasons. Because you won't be exporting energy. You'll be able to save that energy and then use it at a later date and time, which just in conceptual terms is very, very important. And then of course also the resiliency aspect. So yeah, we think that is like really, really important to the industry.
Yes.
This is Commissioner Fishman, and I am trying to imagine a situation, just based on the prior discussion, where you would want to export from a battery and from your solar system at the same time. I just can't imagine why you'd want to do that, but maybe someone could explain that to me.
Well, I mean, go ahead. Sorry, I was going to say that it's not that if there were economic signals in place, or depending on how what the rate and revenue situation was for a system, you could have a market where you wanted them to export everything during peak hours, but that's not typically, in fact, in very few places in the United States is that in place now, and usually that would be prohibited for NEM systems, as we were discussing earlier. So that's why it's really important that we come up with a system of clearly identifying if a system is going to operate simultaneously, it needs to be studied that way. But if it has there's no reason for it to do that, and it has sufficient controls in place to prevent it from doing that, then we don't want to study it as though it is, because it will significantly increase the expected impacts of the system and result in more upgrades. But as you described, Commissioner, right now it's unlikely that there is any incentive in place for a system to do that, especially most behind the meter systems. But there could be, with further market signals in the future for
that. I guess what I'm thinking is that if the solar energy is not being used directly at the home, or business or whatever, and it's being exported, that you're probably not in a situation where there's a good arbitrage reason, if you will, for your battery to be shipping out as well. Prices are probably pretty low. Demand's probably not there. So it's just a hard one to imagine for me. So, but thank you. Your explanation makes a lot of sense.
And maybe one just quick follow on. It would be a situation where the utility would need the extra energy. Say a generator, a large one, went out and they need reserves. They don't have enough reserve. And so they would ask, would you please start exporting everything you've got?
Okay.
So one thing I was going to recommend is many states have pilots that the utilities start to test how to use these batteries in different ways. Exporting just the battery, exporting both, that it needs to be controlled by the utility, really. Thank you.
So I do want to ask a question of you, Dr. Rope. I've had some time to kind of formalize what my thoughts were when reading that last question from Tayoko Sedgwick. that touched on the 100% figure. And I wondered if that was connected to the 100% minimum daytime rule. He's not here to answer that, but would that make sense to you? His question was, one of the screens in the SGIP is 100% of minimum loads. Where does it fall in the context of 50% loads as high penetration? But would that question have arisen in connection with the 100% minimum daytime standard?
Yeah, for solar, yeah, it definitely makes sense to only look at the load period where the PV is active. So yeah, there you'd want to use minimum daytime load, not just minimum load period.
Okay, because I've heard that phrase, 100% minimum daytime, whatever. But okay,
Yeah.
Well, fine. All right.
Yep, that makes sense for solar.
Okay. All right, so we have some more questions now that came in. Let's see, Christine has a question. Are you doing an interconnection workshop from DER projects up to 5 megawatts? Would like to better understand interconnection process and new interconnection considerations in New Mexico for these projects interconnecting to feeders. Yes, we are. Let's see. And then there were some furthers. Hang on a second, folks. Sorry, I lost it. Here we go. Steve Rimesha asks, wait a minute, that's not the right place. Steve Rimesha was asking quite a bit here and there. Steve, are you there? Could you, here actually I found it. Can we please talk more on criteria for closed circuits? I think that's one we haven't gotten to. And then you said it sounds like each utility has different methods and criteria as to when they get concerned.
Yeah, hi, this is Stephen Rimsha. Thank you for the opportunity here. And I understand PNM in their overview, and it relates to my prior question. They talked about thermal stability, potential voltage concerns. I just don't have a good feeling for how they're determining when no more DERs can interconnect, and if we could get better clarity on what they're doing and what the other utilities are doing as they're approaching the same situation potentially, I think that would be really helpful. And we obviously need to talk about it moving forward, but thank you.
Sure, thanks for so much. I appreciate that clarity. So folks, I see you're there, Ruth. Anybody else from the utilities? There's Ryan. Anybody want to address this?
I can try and address it a little bit more, Stephen. Basically, like I said, when we do our review of the application and we look at those feeders, we're basically taking the load and I think Michael mentioned it at minimum daytime load. That was the original way that we used to review them during that daytime, but we are trying to move to actually look at no load because we didn't anticipate the amount of PV that was going to be coming onto the system so quickly over the last few years. So we take all that generation, look at the rated capacity, and when we start to see that PV generation exceed the load or the thermal ratings of the system, then we've basically reached that maximum 100% capacity where we will no longer allow interconnections.
But I'm concerned with how you keep using thermal ratings, but because the way you explain how you're reviewing these systems, how could you ever be concerned about thermal issues on a conductor or within your network? That's where I don't quite understand, because it seems like you're using 100% of estimated daytime minimum load, which unless you've done a really integrated study for a large facility, you have some lateral node that's overloaded for some reason. Like I just don't understand why the whole feeder would be closed based on this, based on the screening criteria you said.
it kind of reverts back to, I think it was Ty that I mentioned earlier. When you look at that rating of the feeder, it's basically that conductor rating of whatever component it is, whether it's at the substation, wherever it is, that total load that's looked at cannot exceed that rating. If you have a 10, kVA rated system and you're trying to install 12 megawatts of solar, you've now exceeded that thermal rating. So we look at it at basically what load we could take off at minimum. If you're still exceeding, then you have that potential for the voltage concerns, because you've now exceeded what load even at minimum is compared to the generation that's on the system.
Yeah, I mean, I'd encourage a detailed presentation in a future meeting. In my experience within utility roles and interconnection processes, I'm really concerned right now. I mean, obviously, you have your own concerns and you have reasons for these closures, but I think we really need clarity in what's going on, because it's affecting customers, and we obviously want to update the rules more broadly, but this is a key issue. So I just welcome any greater transparency, because I'm not hearing the responses that make me comfortable to know what's actually going on. So thank you for those responses, though. I appreciate what you are able to say, and if anyone else wants to add to this conversation.
That's really interesting discourse, guys, and I think it's an important issue that we'll have to definitely have to talk about in the course of our working groups. We got a couple other comments here. Adam Harper from OE Solar says, for the record, regardless of system controls, your solar plus storage export are still limited by the size of the shared common point of intertie, the backfeed device, with the customer's main distribution panel. So that's a comment, not really a question, but does anybody have any further thoughts based on that?
Ken Wilson, yes, I do. Some states put in rules that limit the total amount of export, either from PV or PV plus storage, to not exceed the service capacity limit of the customer's service. So in other words, maybe you have 100 amp service at your house. You shouldn't put equipment that's generating that would exceed that 100 amp maximum. And you can, I mean, it's theoretically possible a customer could do that, but that would really risk tripping circuit breakers at the customer's house or causing other problems. So I have recommended that limit in other states. It should be considered.
Okay. Let's see, and Mark Geiser comments, well, wait, that's a question. Will the discussion on interconnection also touch on vehicle to home and vehicle to grid interconnections and interoperations? That's a good question. I hope we do. I've got a vehicle that runs on electricity, and so I hope we do. I don't see why it shouldn't. Any comments, anybody? Doesn't that seem kind of integral? Yes, Ken?
Well, yeah, so if you, and I have a Leaf in my garage, and so I charge it as you do. We should not be required to do an interconnection agreement for our electric vehicles that just charge from the grid. But if someone eventually gets cars that can export or provide energy to the house while the house is still connected to the grid, then they may need to get an interconnection agreement and go through the application process, because once you start exporting from any kind of a system into the grid, I think we need to see what the capacity is and what that's doing, so that you don't cause problems with your neighbor's house or other people. So that's a very interesting question. So far, most of the interconnection rules are not really dealing with that issue. But as you say, it is coming. The car manufacturers are working on electric vehicles that will do vehicle to home or vehicle to the grid even. And so then we need to consider, when do they need an interconnection agreement with the utility? Thank you.
Thank you, Ken. This makes me reflect on the concept again of exporting from your residence into the grid. And let's imagine a scenario without an RTO, because that doesn't exist everywhere in New Mexico, and it doesn't exist in the PNM footprint, although they're becoming a member of an imbalance market. But I don't know if that market, if the Western Energy Imbalance Market, I don't know if they have any rules concerning aggregated sales in this, for example, from residential systems, aggregated and sold into their system, similar to SPP's rules, which would, work a delay on that school of 3 to 5 years. But barring anything like that, what are the practical concerns from the scenario whereby either individual exporters would like to export in an aggregated situation, and also when I've heard of the hypothetical, and I don't know, maybe it's occurred in places where they do permit aggregation, which I understand occurs in California, whereby the utility seeks to draw on the distributed stored energy to help them out of a spot where they would otherwise need to curtail. Ken, do you have a thought on that?
Yeah, sorry, very briefly, the energy imbalance market is really at the utility level. I think allowing aggregate export would be a decision that utilities in the state would need to make with the commission, how that would be handled and addressed. I think it's really outside of the purview of interconnection rules.
Yeah.
Maybe, yeah, I think that's a different question, how that would be managed.
Yeah, fine. Okay, well, is anybody aware of any other questions? Oh, wait, here's something from Steve Newby. Will there be any effort to standardize the service upgrade required for many solar systems? Down here in the EPE service area, the variety of requirements for such is mind-numbing. So, anybody from EPE like to handle that? Will there be any effort to standardize the service upgrade required for many solar systems? Do we have EPE here anymore?
Commissioner, this is Ty. We don't have anybody from our service department here today, so I think that question is better posed to that group, and we can bring it to their attention and get a response later.
Okay, fine. And posted, how did you say? I didn't quite follow that. That question would be, oh, you mean handled in our process group? You mean the working groups?
If we can handle it there, that would be great.
Okay.
Commissioner, this is Arthur, and I would suggest that if somebody has an issue like that they write it up and be very specific about what they're facing, and they can forward it to the utility, or they can forward it to us, and we can forward it to the utility and make it a data request. the question was very vague, and unless you're involved in that situation, it's a little hard to formulate any kind of answer. So we'd like to see the specifics.
This is Commissioner Fishman, and excuse me, am I being heard here?
Yes, we hear you.
Okay, terrific. And this is for Steve. With those specifics, I'm thinking that this might be an issue that is well handled through a complaint, because this rulemaking could take a long time. And if we're facing current issues, maybe a formal complaint would be one way to get some clarity around it, as long as you're putting together specifics. And so I would suggest that we, not only do you provide the specifics to Commissioner Hall in this rulemaking effort, but also to me, so we can maybe get some quicker resolution of the issues you're facing.
Good thinking. Steve's your commissioner, in case you don't know, in the El Paso electric area. So Eric, I see you popped up. Did you want to say something, or you just decided to smile at us?
Oh, thank you, Commissioner. Just a comment, we were mentioning just a minute ago, the interconnection of electric vehicles. And just to mention that California just very recently, in this past December, adopted an update to the interconnection rules for interconnection of electric vehicles. So that's a very recent development. And basically, in a nutshell, basically saying you can connect a unidirectional charger without the interconnection agreement that stands to reason. And if you do want to interconnect a bidirectional charger, a DC charger, basically with a stationary inverter for DC fast charging, if the inverter is bidirectional capable, then here are the requirements for it. Here are the specific technical requirements defined in the interconnection rule for a bidirectional charger, DC. And if you only want to operate it as unidirectional, even though it's bidirectional capable, you do not need an interconnection agreement. And only if you want to switch it to bidirectional use, bidirectional operation, you actually need to then apply for an interconnection agreement and get that adopted before you can switch that inverter to bidirectional operation. So that's essentially what the rulemaking did.
So that's in California, correct?
That's correct.
And so that was put in place in contemplation of export for aggregation purposes then?
Well, export for really any reason, but bidirectional capability could also be used simply behind the meter, for example, to reduce demand charges to your commercial customer, or if you had a solar and storage system. So it could be for export, or it could be simply for non-export purposes as well. But you'd still have to have the interconnection if the EV charger was bidirectional.
Okay, that's a good issue too. Because I can imagine, wanting to use, I guess, my car battery, if we have a power outage and I run out of whatever's coming from my rooftop system for whatever reason, and I need to draw on my car, for example. That's a good scenario, right, Eric?
Well, there's a whole lot of different use cases for this that I think are going to really be coming to the fore as we start to see the hardware coming. And I know of quite a number of manufacturers that are planning to come up with a bidirectional hardware this year.
Great, that's cool. Okay, we've got more questions from, let's see. Steve Newby asks, no, wait, I just read it. From Adam Harper from Osceola or OE Solar. He says, question, if a future electric car could export its power to a home, an emergency purpose, backup only, that's kind of what I asked, would this trigger a ICA requirement for portable gas power generators to file an interconnection application for approval before use? Who would like to answer that? I don't know what an ICA requirement is, but maybe somebody out there does. Ken's
interconnection agreement. interconnection agreement.
Sure. Okay.
The problem is if the grid goes down and you start exporting, you cause, without some control there, you could cause a power line technician to be electrocuted because they're expecting that the line is down, but now there's energy coming at them. And that's why the inverters shut off when there's an outage. Now, if the inverters, the bidirectional inverters that Eric mentioned, are certified that they don't backfeed in an outage, they don't cause the islanding problem or backfeed during an outage, they shut down, then maybe that's possible. But this is why California is requiring some rules when this happens. So it's a tricky situation that if when we want to be able to do that, we need to look at what California is doing and maybe include some of that in New Mexico's rules.
And Ken, this is Roberto. I think the question is, it's not exporting to the grid. I think it's just as backup to the house and isolating from the grid itself. In those cases, a lot of it is going to depend on the city electrical codes. Not so much connection, but it may be the city electrical codes or the national codes that will define how that, back up to the house only, but not import or isolate from the grid.
Yes, well, yeah, but you need an isolation switch or something to physically then disconnect from the grid.
Yes, it will have to be a manual isolation or a device that it's a break before make that never has the possibility of paralleling with the grid when that vehicle is serving the house.
This is Adam Harper with OE Solar. Just to clarify what I was asking, and maybe it was more of a rhetorical question because like the gentleman just stated, that the New Mexico interconnection standard as well as the National Electric Code already requires a transfer switch or some kind of disconnecting means at the main point of intertie to alleviate any risk of backfeed when the grid is down being worked on or in emergency purposes. So I guess that was kind of my point, is that I don't see why you would arbitrage your car battery power to the grid when you're not going to be able to monetize that when you need that power to go pick up your kids, run groceries, so on and so forth. So if you were looking at using this battery or your car as a backup generator or storage, it would typically be in an emergency setting that you're already going to have that electrical device that is already required to be installed to be able to use your car as that generator. So I'm just kind of getting at, I don't see the difference between a gas-fired generator that you're going to plug into your house when the grid's down, like in Texas, or your car, because you're going to need to have that safety device regardless if it's a car or a gas generator.
Oh, I see. Well, thank you, Adam. I wouldn't want to arbitrage. I wouldn't want to arbitrage unless I could monetize it or unless I needed it for my own home emergency. And I've read that somewhere, I think in the United States, they actually do permit aggregation from residential rooftops and sell into an RTO. I read this some time ago, so I don't remember the details. And then the discussion went further, and if they didn't already have a mechanism for compensating financially the rooftop owners, they were working on it. So that idea just kind of attracted my attention. But ordinarily, no, I don't think I would do that with it. But I understand it is a source that would have been that is possible to use, for your own home use. If if your solar system isn't operating for some reason, the grid goes down. So, but thanks for delving more into that. I appreciate it. Okay, So I think we're getting close to closure time, guys. We are definitely right at 12:59. So unless anybody else has any other questions, I think we'll call it a day. But I thought this was so interesting. I'm seeing lots of thank yous back and forth in the chat. And I just want to thank everybody here. Whether or not you participated, I really appreciate your presence. It shows you're interested and you care. And I definitely want to extend my thanks to all the presenters. You've really enriched my life, and I'm sure everybody else's. And I just want to reiterate our desire to have you guys stay engaged with us as we go forward in this working group process, because it's vitally important that we get this rule in place, and it's vitally important that we get as much intelligent input as we can get. So everything you can do in that regard will help. So thanks very much again. And I'd say we're adjourned for today. Thanks. Bye.
Thank you.
Thank you.